Excellencies, ladies and gentlemen, the webinar is starting in a few minutes. We cordially invite you to be prepared. Thank you. Excellencies, ladies and gentlemen, we would like to express our deepest gratitude and greetings to our distinguished guests and speakers. Honorable Dean of Faculty of Engineering of Universitas Atmajaya Yogyakarta, Doctor of Engineering Lucky Handoko, Honorable keynote speakers, Professor Nizam, PhD, and Professor Mark Aurel Snabel, PhD, Honorable speakers, Professor Prasasto Satwiko, PhD, Professor Veronica Subarto, PhD, Associate Professor Eka Sediadi Rashad, PhD, Associate Professor Tomohiro Fukuda, PhD, Mr. Muhammad Asri, PhD, Profesor A. Joko Budianto, SHR, PhD, Associate Professor Rizal Muslimin, PhD, Professor LMF Purwanto, PhD, and Professor Mo Hamdan Ahmad, PhD. Honorable Head of Architecture Department of Universitas Atmajaya Yogyakarta, Professor Prasasto Satwiko, PhD, and Honorable IWEDA presenters, students, and all participants. Good morning and welcome to IWEDA International Webinar on Digital Architecture that is held on 13 and 14 of December 2021. My name is Henny, and it's a great pleasure serving all of you here today as the MC. And on behalf of the committee, I would like to welcome all of you to this webinar. It is our privilege to have you with us in this today's webinar. Our sincere gratitude to Honorable IWEDA co-hosts and publication partners, the Chairman of International Building Performance Simulation Association Indonesia, the Head of Architecture Departments, Institut Teknologi Nasional Bandung, Unika Sugio Pranoto Semarang, Universitas Aisyah Yogyakarta, Universitas Ciputra Surabaya, Universitas Multimedia Nusantara, Universitas Trisakti, Universitas Warma Dewa, the Chairman of Ikatan Arsitek Indonesia DIY, Editor-in-Chief of Artex, Jurnal Teknik Arsitektur, Editor-in-Chief of Jurnal Modul, and Editor-in-Chief of Jurnal RUHS, Review of Urbanism and Architectural Studies. Excellencies, ladies and gentlemen, let us listen to the national anthem of Indonesia, Indonesia Raya, and followed by the hymn of Universitas Atmajaya Yogyakarta. Let us begin this webinar by seeking the blessing from the Almighty God with a prayer. I will lead the prayer in Catholic. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Lord, as we go to the international webinar on digital architecture, we place ourselves before you, for you are filled with the beauty and light and care deeply about us. Help us to value and appreciate those we are gathered with. May your light enfold us. May your spirit guide us. May your grace abound in us. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Excellencies, ladies and gentlemen, let us listen to the opening speech by Mrs. Kerunisa, PhD, as the chairman of the IWEDA 2021. Mrs. Kerunisa, PhD, time is yours.
Thank you very much, Ms. Hani. His Excellency Professor Nizam, our distinguished delegates, speakers, reviewers, presenters, participants, and our beloved students. Good morning, ladies and gentlemen. Regarding the health protocol, I apologize since I cannot greet you in a full face. So on behalf of the organizing committee, we are delighted to welcome you to the international webinar on digital architecture 2021. Today, we mark our milestone of the first IWEDA, and Department Architecture Universitas Atmajaya Yogyakarta is very proud to be able to host it today here with you all. Before we get started, I would like to express my sincere appreciation to all of you who generously help us make this event come together to become a success. This webinar result of the hard work, support, and dedication of a number of parties. We wish to thank all the organizing committee members who together make the conference possible. And also without the generous support provided by our co-host, International Building Performance Simulation Association Indonesia, Institute of Technology Nasional Bandung, Unika Sugio Pranoto Semarang, Universitas Aisyah Yogyakarta, Universitas Ciputra Surabaya, Universitas Multimedia Nusantara, Universitas Trisakti, Universitas Marwadewa, Ikatan Arsitek Indonesia Yogyakarta, and also our publication partners. We have Artex, Jurnal Modul, and also Jurnal Ruas. This conference would not have been possible at this scale. Last but not least, we thank all the submitters and the reviewers who are the backbone of this conference. The 2021 IWEDA has extended its reach beyond representative of expert, academics, practitioners, and students. The event gathers 2 keynote speakers, 9 panel speakers, 74 presenters, 69 practitioners, 29 general participants, and 88 student participants, with a total number of 271 participants. This very first IWEDA, the next level, challenge anyone to share their brightest idea on embedding the digital technology into the architectural world. 3 main topics: digital architecture, education and work, technology development and digital architecture, the future of architecture design and research influenced by digital architecture will be discussed by the speaker, presenter, and participant within these next 2 days. Throughout this conference, I ask you to stay engaged and keep us proactive and help us shape the future of digital architecture in the region. We look forward to your support to make this event a great success. Please enjoy the event, and today will be fun and full of learning on digital architecture. Thank you very much.
Thank you, Mrs. Kerunisa. Excellencies,
We would like to apologize that Miss Henny had technical issue, and I'm Joshua. I will be the co-MC for today's event. So we will continue our session today. We would like to apologize that Prof. Yoyong Arfiandi as Director of UAJ cannot join us today. And therefore, we would like to invite the Dean of Faculty of Engineering, Universitas Atmajaya Yogyakarta to deliver the opening remarks, as well as to officially open the International Webinar on Digital Architecture, 13 until 14 of December 2021. Please welcome the Honorable Doctor of Engineering, Lucky Handoko. Mr. Lucky Handoko, time is yours. We would like to apologize that Doctor of Engineering Lucky Handoko still have technical issue about the internet connection. Okay. We would like to say sorry about the technical issue. So we would like to invite Mr. Doctor of Engineering Lucky Handoko. Mr. Lucky Handoko, time is yours.
Okay, thank you very much. So I'm sorry for the technical issue that happening just before I deliver the opening remarks. So as introduced by the MC, I'm Lucky Handoko, Dean of Faculty of Engineering, Universitas Atmajaya, Yogyakarta. I'm here on behalf of Professor Yoyong Arfiandi as Director of Universitas Atmajaya Yogyakarta, who's supposed to deliver the opening remarks today. Unfortunately, he has unexpected, inevitable agenda this morning, and he's sorry for that, and he sends his warm regards to all of you. Especially, it will be a great moment to mention the honorable keynote speaker for the webinar, Professor Nizam, Director of General Higher Education, Ministry of Education and Culture from Government of Indonesia, and Professor Mark Aurel Scabel from Victoria University of Wellington and Digital Architecture Research Alliance. Honorable guests, distinguished speakers, and participants, good morning to all of you. At least for those who live in the west part of Indonesia or at other part in the same time
Ladies and gentlemen, it seems like Mr. Luki has a technical issue in his connection, so we would like to apologize on his behalf. And once again, we are sorry for the inconvenience that we just experienced.
Okay, MC, can you hear my voice? Okay. Hello there. Hello, MC.
Yes, sir.
Yeah, I'm back now already.
Yes, I will give back the time to you.
So can I continue?
Yes, please. Thank you.
Okay, so where the part I left, I don't know. So because I just continue my opening remarks and I don't know where the part I left. Can you inform me?
Maybe you can start all over again, sir.
All over again. Okay. Okay, so I am sorry for this situation. So it's a problem for all webinar when we are doing it virtually. We have a problem when the connection is not good. So just now the connection in campus is just goes down again. So I
I changed my device to my phone. So I'm sorry, I'm not wearing any background now because I have not prepared any of the background for this device. So okay, I will start from the beginning again for this opening remark. So as introduced by the MC, I'm Luki Handoko. I'm the Dean of the Faculty of Engineering, Universitas Atmajaya Yogyakarta. Here, I am on behalf of Professor Yoyong Arfiadi, because he is a director of Universitas Atmajaya Yogyakarta. He's supposed to deliver the opening remark, but unfortunately, he has the unexpected and inevitable agenda this morning. So he is sorry for that, and he's sending his warm regards to all of you. So especially, I would like to greet all the keynote speakers, the Professor Nizam, Director of General of Higher Education, Ministry of Education and Culture, Government of Indonesia. And also for Professor Mark Aurel Scabel from Victoria University of Wellington and Digital Architecture Research Alliance. Honorable guests, distinguished speakers and participants, good morning for all of you. It's a great pleasure to be here to welcome you in the 2021 International Webinar on Digital Architecture. The word digital has been mentioned a lot these days. This related to the use of the computers in all of our activities, in our ideas. Changing our traditional paradigm is not easy. We have many challenges to overcome. We cannot just use our traditional way into the digital world. We have to realize that computer is only a tool to help us. We need to change our mindset into a new paradigm. We must take the advantage of the rapid technology advancement. The COVID-19 pandemic that has been hit the entire world has also contributed to the acceleration into the digital transformation. We must not stay into the old paradigm, but we must advance to the next level. This webinar is expected to be a place for the researcher, for the practitioner to meet, to discuss, and exchanging experiences about this inevitable transformation, especially related to the digital architecture, which has been becoming the direction of the development for the Department of Architecture in Universitas Atmajaya Yogyakarta. And we hope to contribute to the demand in the digital transformation. Well, I'm not going to hold you any longer. Happy webinar, enjoy the webinar, and I wish you to have a productive and fruitful discussion. And I hope this international webinar will take you to the next level. So thank you very much.
Thank you, Dr. Luki, for the speech. Now we would like to inform all of the participants about the webinar rules. Rules for today's webinar. Participants should mute the microphone during the presentation. Participants should follow the agenda until the end of the sessions. Any question related to this event may be asked to host or via chat room. Please follow the rules mentioned by moderator. So, ladies and gentlemen, the committee will take picture of us by taking a screenshot of the Zoom screen. So we invite all the participants to turn on the webcam. Since we have so many participants, the committee will take a screenshot per slide, and I will count to 3 for each slide. Let us start from the first slide. Next, for the second slide. Next, the third slide. Next, the fourth slide. The fifth slide. The sixth slide. Okay, we're done. So we will continue to the next agenda. Ladies and gentlemen, the International Webinar on Digital Architecture 2021 that is held today, 13th of December until tomorrow, Tuesday, 14th of December, is divided into 3 panel discussions. For today's session, we will have 2 panels. With the first panel is on the education and practical works. And the second panel is about the technology development of digital architecture, or DA. The third panel that will be delivered tomorrow is on the future of architecture design and research as influenced by digital architecture. Before we begin with the panel discussion, let us listen to the presentation from our first keynote speaker, Prof. Nizam, PhD. Prof. Nizam, PhD, is a professor in civil engineering at Gajah Mada University and currently also served as the Director General of Higher Education, Research and Technology, Ministry of Education, Culture, Research and Technology, Government of Indonesia. He has broad-based research interests covering coastal engineering, disaster mitigation, ICT in education, and higher education planning and development. He consults part-time on disaster mitigation and higher education reform projects with GICA, Asian Development Bank, and the World Bank in Indonesia and Sri Lanka. Numerous publications, including books and articles on higher education development issues, disaster management, coastal dynamics, infrastructure development, information and communication technology, and knowledge for development. Numerous speeches in public conference and seminar in Indonesia and overseas Indonesia representative to UNESCO conference related to higher education. Unfortunately, now Mr. Professor Nizam cannot join us and he has already sent the video. And after this, we will watch together the presentation from Mr. Nizam.
How does digital technology reshape architecture education? I'm Veronica Subarta, Professor of Architectural Science from. How does digital technology reshape architecture education? I'm Veronica Subarta.
salam sehat, salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan. Honorable Rector of Universitas Atmajaya, Prof. Yoyong Arfiadi, distinguished speakers, participants, guests, ladies and gentlemen. First of all, I would like to welcome all participants into the International Webinar on Digital Architecture, or IWEDA 2021. My appreciations to Universitas Atmajaya in hosting this very interesting international webinar on digital architectures. Now digital technology has reached its maturity. As Gordon Morse predicted more than half a century ago, that the computing power double every 2 years, while the cost half at the same rate. The advancement of computer powers has made it possible to do calculation-intensive graphical transformations and rendering at the cost that is getting more and more affordable. With such development, the fields of architectures, like finding new pencils in expressing the ideas, expressing the spirit of architects in developing space and built environment, even beyond the imaginations. The digital architecture is now going into maturity and become parts of the competencies of any architects living today. However, the development of new technology, especially the advancement of artificial intelligence, machine learning, opening up new horizons, which even go beyond our imaginations. The digital architectures now enters a new world with technologies such as virtual reality, augmented reality, which is now become part of the architecture's life. Holography, I think, is another technology that is coming in our visual world and opening new possibilities beyond our imaginations. Therefore, it is very interesting time that we are experiencing, where creativity enhanced by technology expand our horizons, expands our creativity beyond what we can imagine before. One important thing is that now the coming of the technology and the coming of creativity need us to work more collaboratively across discipline, across fields of discipline, because without collaborations, the imagination could not be realized into real physical built environment, as well as the technology itself need other competencies that go beyond what one can master individually. Therefore, co-creations and collaborations become an area where every architect has to get into. Higher education and the advancement of AI, of virtual reality, VR, augmented reality, holography, all this development in the digital technology can be integrated, can be collaborated with architecture's fields to create a new world of architectures. It is what we call the Industry 4.0, which basically we merge between the virtual world and the real world, the physical world, and connecting dots of competencies. And what is most important is that technology should serve the humanity. That is what we call the Society 5.0, where humanity is on top of the pyramid to be served by technology. I hope this seminar will be a fruitful forum for everyone to share new ideas, to share advancement of research and development, as well as to establish collaborations between all participants joining this webinar. I wish you all the best, and I hope from this seminar some cooperations between partners can be established, and advancement of architectures will be accelerated. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Shalom. Om Santi 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 Om.
Thank you. And Ms. Henny will continue for the next session. And Ms. Henny, time is yours.
Thank you, Mr. Joshua. Ladies and gentlemen, as a symbol of our gratitude and appreciation, we would like to present an e-certificate to our keynote speaker, Professor Nizam, PhD, as shown in the slide. Thank you. Excellencies, ladies and gentlemen, before we jump to the first panel discussion, we will have a short preparation for it, so please wait for a minute. Thank you. Excellencies, ladies and gentlemen, let me introduce you to the moderator of IWEDA 2021 during this first panel discussion, Assistant Professor Nyoman Gede Mahaputra, PhD. Mr. Inyoman Gede Mahaputra is the head of Architecture Department in Universitas Warmadewa. He completed his architecture education from Universitas Udayana and obtained his master in urban planning from Erasmus University, Rotterdam. He obtained his doctorate in urban design from Oxford Brookes University. His research interests include places, place identity, history of architecture, and urban design. Assistant Professor Nyoman Gede Mahaputra, PhD, we invite you to lead the discussion. The discussion shall finish at 12:25 WIB or GMT +7, including the session for question and answer. The time is yours.
Thank you, Ibu Francisca, for giving me the chance to chair the sessions. Okay, this session is the first session of today's seminars where we will discuss the focus of this session will be on the education and practical works. And we have three speakers for this session. The first one is Professor Insinyur Prasasto Satwiko. The second one is Professor Veronica Subarto, and the third one is Associate Professor Eka Setiadi Rashad. I will introduce you all to the speakers. Our first speaker is Professor Prasasto Satwiko, MBuild SC PhD, with the presentation title From Science Fiction to Science Fact. Is digital architecture potential exaggerated? It is a question, ya, Pak Sas, ya. Prof. Sas, as he widely known, is teaching, researching, and designing projects, and also writing books. He has numerous books. His fields and interests are building performance, computer simulations, which include natural and artificial ventilations, natural and artificial lighting, non-electronic and electronic acoustic, including energy and digital architecture. I heard that Pak Sas is a favorite teacher among his students. It's true, Pak Sas. Many of you students says that you are their favorites in Atma Jaya.
Thank you, thank you.
One of your students is my best college in Bali. Pak Sas is graduated from School of Architecture, Victoria University in New Zealand, both for the PhD in Architecture and Building Science and Master of Building Science, where he obtained it as first class honor. He has numerous projects and current managerial position.
I think we have another technical problem.
Sorry, the Zoom was interrupted.
Yes.
Sorry for that, Pak Prof. Okay, without
No
further ado,
worries.
I will pass this session to Pak Sas. Please, Pak Sas.
Thank you, thank you. Nyaman, yeah. Thank you, Mr. Moderator. Yes, I hope we won't have another problem with our Zoom. It seems that everyone wants to join this webinar, so the line is overloaded. Okay, thank you. Before I move on, can you hear clearly my voice?
Yes, very clear, Pak Sas.
Okay, thank you. Thank you. Let me share my screen. Have you seen my screen? Mr. Moderator?
Yes.
Okay, thank you. Okay, thank you again, Mr. Moderator, ladies and gentlemen, brothers and sisters. Initially, the title of my presentation is From Science Fiction to Science Fact. Is the digital architecture potential exaggerated? But then, after long thought, I slightly changed the title to From Science Fiction to Science Fact, Digital Architects. Yes, I said digital architects, not digital architecture. Yeah. Every morning, the artificial intelligence of Google News briefs me with updates on AI. I am amazed by the fast development of digital technology, particularly in brain-computer interaction. Some futurists forecast that in 2045, computer capability will meet human brain capability once. Some of them speculate that that is the era of autonomous computer, which think independently without human supervision or intervention. For example, a digital architect is a machine that can design a building. I take two propositions for my paper. Sometimes my colleagues warn me that a computer would never be better than a human. Computer is just a tool to serve humans in processing data. More than that, just like other tools which human makes to help them. Yes, I agree with their statement, but I would say that their statement is a more theological view. A man will never be better than God, his creator. That's my first proposition. Why do we make tools? We create tools to fulfill our needs and to overcome our limitations. For example, we make a crane lift heavy objects. We make airplanes so we can fly, and so on. So humans create a tool to help them do a job. It can be a repetitive and tedious job, dangerous job, or a heavyweight job. So a tool should be better than its creator in doing a particular job. If it is not better, there's no point in creating it. It is my second proposition. Computer was invented to help us quickly, precisely, and accurately process big data. We, humans, are not perfect. Making mistakes is our nature. So why don't we create something better than us? Nowadays, we see the advanced development of artificial intelligence, as we have never seen before. We also witness significant progress in the autonomous robot. So why don't we architects be prepared for the unexpected future? A couple of months ago, I came across an article with the title, Will Artificial Intelligence Kill Architects? An insight on the architect jobs in the AI future. While this article doesn't mention anything about digital architects replacing human architects, it does underline the AI's impact on architect jobs. So the purpose of my speech are to explore future possibilities of architecture design in the artificial intelligence era and to self prepare for the incoming disrupting era. My ongoing research is based on a literature study. It starts by exploring the state of the art of artificial intelligence, then exploring the trend in digital architecture, discussing the possibility of digital architects, drawing conclusion, and offering a recommendation. Basically, my research reviews progress in AI published in reputable journals and surveys on the internet about the trending phenomenon of using AI to replace the human brain. The trend forces humans to be aware of AI's impact in many areas of life. For example, replacing the activity of human architects with computers may entirely be about time. The term digital architecture refers to digital technology usage and architecture practice. The presence of digital technology fills the gaps in the conventional design process. Further detail architecture exploration have made how previously unimaginable building forms can come to life. It's now also possible to build unconventional architecture forms because of digital fabrication technology. Digital architecture is maturing. Currently, digital technology usage and architecture is no longer limited to an architectural presentation tool. Digital technology has become a tool for thinking. Computers can currently be involved in the architect's thinking process, becoming like an external brain. However, the thinking process does not occur entirely in the architect's brain. Architectural design is a rational process that systematic arrangements is possible. In the past, Vitruvius divided architectural aspects into three, namely firmitas or strength, utilitas or utility, and venustas or beauty. Today, these three aspects remain valid but have grown more complex and detailed. Although said to be logical, architectural design involves tangible and intangible, and real and abstract matters. These features, in return, affect the position of architectural education in many universities. Some architectural education are put in the engineering field, while some include them in the arts field. Engineering relates to hard sciences, relatively straightforward with numbers. Meanwhile, arts are soft sciences. Architecture's aesthetic aspects, or venustas, may involve arts driven by emotion. Human emotions are closely related to psychological matters, currently regarded as non-existent in computers. It has been the subject of studies and debates whether robots can have the feeling required to create works of art. Computers may have the capacity to produce image or music, for example, that seems appealing. Not all humans can create beautiful works of art. Meanwhile, computers can produce something that is considered artistic by humans. Computational creativity is still a matter of debate. Currently, AI is used for analysis and synthesis in building environment design, not in the creative process. Nevertheless, the involvement of AI in the art world continues to grow, so that the role of AI in the art aspects in the context of architecture is not impossible. If AI cannot replace human creativity at this time, at least AI can increase human creativity. This slide triggers the theoretical concept of the realization of a digital architect. We define the digital architect as an artificial intelligence-powered software that can think like architects or human architects. People used to believe that computers would never imitate and supersede the role of architects regarding creativity and imagination. However, the defeat of the world chess champion, Garry Kasparov, by Deep Blue, made by IBM, and game champion Go, by AlphaGo, seek the monopoly of imagination as uniquely human property. The two games represent the superiority of human in creativity and feelings. And the wins are still under debate. Many argue that the advantage of computer is only in their ability to process information faster. However, the study showed that generating floor plans with AI is now possible. Another study showed developing 3D building design with the generative adversarial network was also attainable. How can computers provide creative solutions? Algorithms help the software process data and determine the most mathematically plausible solution in both cases. Now, perhaps the answer lies in a more philosophical question. What is creativity? Is the creative process independent from general logic? Consequently, the answer may aid in providing more groundbreaking software for architects. Humans have long dreamed of a machine with whom they can communicate. Robots, now we know as ordinary computers in general, fulfill the descriptions a bit. We can parallel the conception of how humans built robots and how God formed humans according to the Genesis creation narrative. Both creations represent the Creator's images. Moreover, both are born to work. The Bible views humans as God's workers who rule over the earth. Meanwhile, the word robot means forced labor, first introduced by Karel Capek in 1921. Thus, the idea of robot as helpers for humans has existed since the beginning. Let me conclude my speech. This slide shows the idea of digital architects. Just imagine we have an internet-based computer equipped with AI. It can access any data in the cloud, which supports the architecture design process. Just imagine an ordinary woman wants to design a house, so she inputs what she expects to be her dominant preferences, such as size, price, style, and location. Computer checks all data available in the cloud relevant to the inputs, including design precedents. It then offers some design alternatives for the woman to check which one is the closest to her preference. The process can be iterative until the woman is satisfied. Once she confirms her acceptance, the computer will prepare all the required documents to send to a constructor. As a bonus, the computer will also upload the resulting design to the cloud to enrich the cloud vocabulary on architecture design. For the future of architecture education, I would recommend a new paradigm. I call it the artificial intelligent rural architecture, or AINA. Let me finish my speech with 3 points. First, advanced artificial intelligence technology has made the digital architect's existence possible. Secondly, digital architects will likely replace human architects. Thirdly, it is up to the architects whether to give their jobs to the digital architects or work with them to open new possibilities in the architecture world. This is actually my simple recommendation. Thank you. Thank you very much.
Thank you, Prof. Sas. What an interesting conclusions. You said that maybe human architect will be replaced by digital architects, and you are focusing on the creators, not the creations, ya, Pak Sas, ya. For all participants, if you have any question, you can post on the chat box with the format as mentioned by Prodi Architecture UAJY. Yeah, you can post your question by filling out your name, your affiliation, and to who your questions are posed. And our second speakers will be from University of Adelaide, Professor Veronica Subarto. Her presentation will discuss how digital technology reshape architecture education. So it will be focusing on the education, on the architecture education. Professor Veronica joined the University of Adelaide in 1998 after completing a postdoctorate research associate position at Texas A&M University in College Station, Texas, USA. And he finishes her PhD and Master of Architecture degree from the same university. She is now the leader of the Sustainability Research Group, and her research interests span very wide from its friendly building environment, environmental performance assessments of buildings, building performance simulations, building monitoring, human thermal comfort, to the social dimension of sustainable designs. She will do asynchronous presentations, and I think the committee could you please help me play her video, please? Thank you.
How does digital technology reshape architecture education? I'm Veronica Subarto, Professor of Architectural Science from the School of Architecture and Built Environment at the University of Adelaide in Australia. So I'm going to address this question through three things. One is to look at a little bit of history of digital technology or the use of digital technology in our school, how that impact on architecture education in our school, and what I think we go from here. So as you all know, digital technology can be used in different forms or for different purposes. So these are some of the use or usage of digital technologies in architecture schools. Now in our school, probably the same as many other schools, architecture schools around the world, we started off by teaching students with manual drawing. I moved to Adelaide in late 1990s, but even before I arrived, I understood that we started teaching CAD or computer-aided design, particularly using Form Z or Form Z, which was at the time one of the main CAD programs on Apple computer. At the same time, we also taught AutoCAD, so 2D drafting, which then also you could do 3D axonometric drawing and so on. With Form Z, you could really come up with intricate design, and that's why we loved Form Z at the time. It can be quite flexible and quite explorative. And this is one of the highlights at the time. Students, well, he's no longer a student, obviously now he's an architect in Chicago, but Tristan, he designed a experimental dance studio where it's using pneumatic principle, where the shape and the shell or the wall, which becomes the roof shape, is affected by the wind that blows on it, so it actually can move and so on, which obviously it's really difficult to demonstrate this kind of design or explore design if you use hand drawing. You could do it with physical model, but as soon as you want to make changes, obviously you then have to make changes to the model. At the same time, when I arrived and I taught this energy analysis, it's kind of more using 2D, very rough sketching tool, this program called Enerwin, which I helped develop the interface when I was at Texas A&M University with Professor Larry Dagelman, where students can sketch a simple design and then
define the roof, the ceiling height, I'm sorry, and then define all the building materials, thermal properties of materials, the occupancy, and of course, place it in a particular location and put weather data file into it. And then the program predicts, for example, how much contribution all of each components of the building have on the peak cooling load or peak heating load, or also looking at indoor comfort if the building doesn't use air conditioning. And also I then subsequently developed the tool where we could compare the performance of the building against reference building. We dropped using FOAM-Z simply because FOAM-Z at the time, as I mentioned, was used on Apple computers, and the university decided not to support computers that are not PC or personal computer or Microsoft based. And so we cannot use FOAM-Z anymore, and we move on to use SketchUp. Design and drafting software package called ArchiCAD. Some of you know ArchiCAD, where you can draw buildings on 2D, but also 3D, and also assign materials and so on. We also taught Autodesk 3D Max, so where you can use your AutoCAD file and then put materials and light source and so on, where you can then represent the surfaces, and therefore becomes a bit more kind of photorealistic kind of presentation. So with Ecotech, you can visualize the building in 3D. You can look at, for example, solar radiation, understanding solar paths, and then also performing similar energy simulation like Enerwind did. In Australia, we also have an energy rating tool, which means you can predict the performance of a building before it is built. And as a matter of fact, this is a way to get a compliance for approval and comparing it to the reference or the target not to exceed. So building has to be less than certain amount to be considered meeting the requirement for the compliance to the building energy code. So that program called Accurate. And also we taught students a bit bigger environmental performance assessment tools, such as Neighbors, which assess energy use and water, as well as a big, larger environmental assessment tool called Green Star, which is similar to Greenship, where we look at not just energy, but indoor environment quality, water use, waste, and so on. Maybe this is a bit too late. Actually, we started teaching rhinoceros, or rhino, we often call it, which is a newer package, software package, where you can really use it to design. So it's not necessarily for drafting, it's really a design form making tool, where really, particularly with the use of Grasshopper, which is a plugin where you then can write a script in a way or coding it. So you really come up with parametric modeling. At the same time, we also taught or started teaching a 3D modeling drafting package, which is Revit, which then it becomes a platform for building information modeling. Back to Rhino, then, as I mentioned, we can also use it for environmental analysis using plugins such as Ladybug and Honeybee, where you can look at solar radiation analysis, daylight analysis, also energy consumption, energy use in building, thermal comfort, looking at psychrometric chart, and so on. So we can really look at as students design the building. You can use this as a design process started. But really the power of Rhino, as back again, is really using the Grasshopper and any other plugins such as Karamba, where you can look at structural analysis and really analyze the structure of a building while you're designing the form and the shape. For the higher level, we also taught other tools that are used in practice. So one of the tools that we taught students are this program called Design Builder, which is doing an energy comfort, airflow analysis. Also, it could be used for energy compliance. We also taught IES VE, virtual environment, similarly, where you can also visualize, so similar to Ecotech, I guess, we can visualize environmental analysis, but with more detailed system simulation, so heating, cooling system, if we wish to teach that. All right, so the other thing also with digital technology is then using the same file, as you know, particularly like file like Rhino, we can print the model. So instead of such as, you know, traditionally we have hand sketch drawing, which turn into more drawing with, you know, proper scale rulers and so on, and then you build physical models separately. Now with digital file, we can, they often, some of them also use it throughout the process. The problem with the 3D printing, which I will talk about later, is that because it can be costly, so it's much quicker if students develop the design through hand modeling, and then they come up with the final design, and then 3D printed the model. Of course, digital technology is used for not just design, but throughout the presentation, as I already mentioned, with the physical modeling, but also creating posters, where we usually normally either students use Adobe Photoshop or InDesign. Lately, we use InDesign more so. And of course, with the invention of digital technology for constructing buildings, now we can also use digital method to construct a building. This is not our project. This photograph actually was a photograph of a demonstration building by a company in Morocco. But one of our PhD students started to explore the use of 3D printing in principle, or digital fabrication using robotic arm to create real building materials, or in this case, wall material, onto one-to-one scale. So this work is by Muhammad Goma, who now works at RMIT in Melbourne. So the idea here is using earth materials, because earth material has low embodied energy, and using this high tech to create low embodied energy material. And imagine if you have to have workers working on creating building, and you're going to have trucks bringing in materials and so on, it can be quite costly. Whereas this one, the idea is a robot can just come to the site and with material prepared on site, and then you can build a building using this technology. And with robotic arms, you can even create quite intricate designs. And of course, in the past 2 years, digital technology has helped us communicate in the virtual world. And this is the reason also why I can deliver this, this talk, even though I'm not in Indonesia, able to hear or to see. This technology has allowed us to do this. And not only for communication, we also can use it for representing design to client using AR or augmented reality or VR, virtual reality, where the client, for example, can see what the building could look like or will look like before the building actually is built. So it really could save money. It also can be used with, for design communication during studio or exploration of design. So some reflection. Yes, digital technology really is now allowing students to explore any kind of exploration that probably previously was not that possible. It allows integration with analysis during the design process. It could also allow design automation. But obviously, in terms of affecting architecture education, we now require a lot more time to teach the tools because there's so many tools out there, and we have to be selective about the tools to be used. And so in addition to teaching them at the university, we also ask students to really use online resources because they really have to catch up with so many different options and changes that are available out there. But really having digital technology allow us as a teacher to be more hands-off. We don't tell students, this is the prescription, this is what you need to do, because the tools are out there to explore so many options. So students are allowed to create or to do what if then scenarios much more easily than before, and understand the consequences of design decisions themselves because they experience all the exploration themselves. So I think that is the benefit. But on the downside, it has problems as well, because the ability of students using digital technology and be able to design using CAD programs really depends on their knowledge, understanding, and skills in using that tool. The other problem we see is because now students tend to design on the computer screen, no longer in a big piece of paper like I used to do, there is a sense of they don't see building that actually in reality would be, say, 20-meter high, 50-meter tall, and they see it as an object. They see it from the air as if the building is so small. Some of them kind of lost the sense of scale and reality because also they can just model everything. Often we saw students, so assuming that a roof can just fly and can extend to 10-meter long because you can model it. But when we ask, how do you support it in reality? And they just couldn't visualize it, couldn't think that in reality it may not happen. So that is a problem that needs to be addressed a lot by really putting the sense of reality back to their virtual reality in designing. In terms of drafting, of course, it can provide more precise drawing, but the drawing itself into one-to-one scale. So the chance of making a mistake is less so with digital technology than with the hand drawing. And also with the interaction between tools, software, where the modeling tool can become a CAD tool, a drafting tool, excuse me. So then it can be seamless. And you can also use the same file, for example, to then send it to the printer, and then you can print the model and so on. And even now you can construct that. So it can be quite seamless if you know how to do it. But of course, in terms of affecting our system, our education system, again, I said that we need to spend a lot of time for students to learn the tools, but also need to make us think about how to teach. This is in terms of drafting, right? How to teach drawing convention, just as an example. And we found this a lot or often happen. Before, when we teach 2D drawing with hand drawing, we said, okay, if you draw an elevation, use 0.2 pen, for example. And then for building components that are cut in a section, use 0.6 pen. Well, on a computer software, that's not what you do. What you do is you create different layers and then you assign different thickness to those layers. If we don't watch what the students do, often they create different layers and they forget to change the thickness, because what they see, whether they change the thickness or not, the drawing would still show as the same thickness. It just have different colors. So on the screen, things could look different. But when you print it, if you print it in black and white, then they all look the same. Then they don't see which one has to be cut or with a thicker line unless they change the line thickness of that layer. So that's a way of, different way of doing it. So you need, as a teacher, you need to rethink how you teach, say, drawing convention. Also, because there's a potential of just simply generating the 2D drawings from the 3D models, often, how to present that in a drafting convention, it can be quite challenging, because unless you really then select part of the drawings that are not supposed to be there in the 3D drawings, in the 2D drawings, sorry, the drafting or the construction drawing could not be accurate, because there's a temptation of just using shortcuts, simply cut the 3D model, and you cannot really differentiate between things that are cut and things that actually appear on the background. So to clarify, I'm just giving this example. So this is a student project that was drawn as a, the person modeled it really in 3D. And then what happened here is the student then simply used the 3D model and looking at one side and draw the elevation. Okay, now in the actual elevation, if you are really just looking at the outside of the building, is everything shown here really going to appear? It's really hard to tell, because when you model, everything is there. So unless you're really selective in drawing the elevation, sometimes the lines that are representing in the 3D model still show up in the foreground. So you really need to be careful with that, especially when you draw a section, because the section is simply cut from the 3D drawing. Often it's not clear, okay, what is this constructed of? Because in the model, it doesn't really matter, because what you model, let's say, is just the floorboard. But obviously, the floorboard cannot just stand on its own. It has to have some structures underneath it. It has to have the beams and so on. Those beams are not needed in representing the design, but it's needed in the construction drawing. So if you just simply cut it from the model, your construction drawing in the section may not be accurate. So that's, again, things that we have to address over and over in teaching drafting using digital method. In terms of representation, again, we already said that this 3D representation using digital modeling can produce really realistic image. So for example, this particular student of mine, you know, that's how the building he wanted to look like. So you can put materials, you can put certain surfaces of the real materials and represent it, render it, and it looks pretty much almost like a real design, real building. But also you can choose to make it more abstractive, as long as what you want to do or they want to do is just representing the essence of the design. So again, how it affects architecture education, of course, time to learn is the tool. But what we emphasize, at least in our school, is that we teach the principles that it's about representing the idea. That's more important. So what is the message that the students want to convey is what we teach. And we also teach, you know, layout, composition, hierarchy of the presentation, but we don't teach the exact way of representing everything. Why? Because again, there's so many choices now that students can explore. So we allow students to explore rather than being told what to do. But again, as I mentioned, there's the chance of easy to losing the sense of scale, because again, students work on the screen. They don't see things in a sort of bigger backdrop or bigger area of representation of their design. Also, one thing is it's so easy to manipulate things when you use digital representation, because you can just create more lights or create more seductive representation, and it could hide the design flaw simply because, you know, the image looks beautiful and seductive, but once you look at the floor plan, for example, or the space planning, it might not work. So you really need to, as a teacher, you really need to be careful in looking at the drawing of students. This is another example. So it's a fantastic design, but there are issues. So for example, this is a design from the same site that I showed you before, but the site is actually quite small. The student actually designed, if we measure the measurement of this building, it actually wider than the site available, okay? But, so if they use this actual model, their own model, the building actually quite wide. And the student wanted to represent it on the actual side, so then they put it on the side. But because you can easily scale it up and scale it down, this building actually gets scaled down and it looks like it would fit. But if you really measure on site, the building actually should have been much bigger than that, which means it won't fit on the side. Again, when you import an image, for example, onto a paper or for your representation, you do copy and paste. Sometimes you accidentally stretch it, and then all of a sudden building gets squeezed or distorted and so on. So it's easy to make those mistakes because the tool allows you to do everything. So that's something that can affect, you know, the way we teach and the way students also learn about design and representation. In terms of for digital fabrication, digital technology really can push the limit or beyond the limit of the boundary of normal construction. And as I mentioned before, it doesn't require a lot of space theoretically, because imagine if you have to build physical model and you have to need, you need a table, you need to have cutter, you need to have glue, you need to do a lot of things, and you create a lot of mess. With this, you send the file to the 3D printing studio, and within a few hours, the model is there. You pick it up and you don't make much mess. However, there is a downside, of course. Digital or 3D printing technology, robotic arm, 3D printer, they are pretty costly. Number two, you also need to consider the resources, because not only electricity, but also the materials for the printing, because not every material can be used for 3D printers. And also the material that is wasted, because the material tend to come as, say a board, a certain width, a certain dimension, and then it's cut. And what do you do with the rest? Because you cannot just simply put it back into the printer. Whereas with handmade model, the leftover, you can use it again, you can cut it and you can use it for something else. So the leftover material is a big question for this and needs to be rethought carefully. Maintenance of the equipment, of course, and the room itself. You need to provide a good ventilation system because of the fume that comes out of the machine. And also the materials that are used, and therefore the quality of the model or how it give impression to the people who are looking at the model can also be limited to by what the machine can do. As I mentioned, not every material can be put into the 3D printing machine or to the robotic arm. In terms of analysis, again, of course, with digital technology, you can almost do almost everything if the softwares are available, whether it's an analysis of design, temperature, relative humidity, air quality, visual, lighting, acoustics, and so on. And that can be done simultaneously during the design process. That's really, really the power of digital technology. So you don't just design and then do calculation after that, which is what used to happen in the old days. And therefore, this technology can provide confidence to students to really understand the consequences of the design. In a way, it's kind of providing evidence before the building actually is built. So it really brings design and science closer. But of course, you do need to have teachers who really are knowledgeable about the tools that are used. Because with digital technology, with any computer software or simulation, it's so easy, what I call it, to produce garbage. Because if you put in the wrong input, you can get an output, of course, but that output could be a garbage, could be a wrong output. For example, there's so many different examples of students just entering something wrong, and if it didn't get checked, they made a conclusion based on wrong simulation. So that's really the downside of this, that you really require teachers that really know what the software is doing. And also you need to be selective because there's so many tools out there that are not necessarily producing the right outcome. Finally, for digital communication, as I already mentioned, that this digital communication really allows students to learn from everywhere. I mean, the fact that I can talk to you now, although it's recorded, I'm not in Indonesia, but you can learn from what I share with you, and hopefully I can also learn from what you share through listening to the recording later on. So we can be more informed, updated more frequently because technology allows us to happen. And the nice thing also with this is, particularly in the last 2 years when we have to teach remotely, when we give feedback to one student and even working on their, on the screen, this is our feedback, we scribble on their work, 100 other students can see it at the same time. Whereas in the studio, physical studio, when we work on students' work or put comments, maybe at the most 3-4 people around the table can see it because, not 100 people can look at that. But now, so learning from this, what we do now is we tend to put a camera in our studio, we project it to the screen so other students can also see what we do. So that's really, again, the benefit of using this digital technology. But again, how it affects our architecture education, we really need to rethink our teaching delivery. It's really not just one way we teach, the teacher talk and the students listen. It's really 2 ways interaction, or even, 100 ways interaction, because all other people can collaborate at the same time. But also engaging students in the virtual world can be challenging, particularly when we talk about communicating, say, with Zoom. You know why? Because students can choose to turn off their camera. So we don't really know if they're there or not. Whereas if they're in the room, we know whether they're engaged or engaging with the student, with the activities or not. With the Zoom, once they turn off the camera, although they claim they're there, who knows? They're probably going to the kitchen, have some nice, I don't know, mie goreng or something like that. So in summary, I think digital technology is here, is now, is in the future. And I think we just have to embrace that there's so many benefits of this in architecture education. It allows multiple interactions with different with different tools based on this IT platform. We can do design, drafting, fabrication, analysis, it seamlessly. It allows more exploratory activities by students, and it should allow us to teach more effectively. But it could also mean it's more complex because we have to plan in advance and then provide enough time to really explore all of this possibility and how to integrate it. Once we can do that, the delivery becomes easier. And I said also already that it allows us have 2-way interactions, students with teachers, students to students from all over the world, unconstrained by location. A few things I like to mention though, as an educator, I think we really need to be more vigilant as well. We found that since we use, digital technology, internet is there, people can look at work from everywhere. The problem is students can copy work a lot more easily now than before, because they just can plagiarize, change here and there, and manipulate work much more easily. So we really have to be vigilant. We put in place plagiarizing scanning tool, and sadly, often we found a lot of students did plagiarize other people's work from the internet because it's so easy to make that copy. And also just watch out, as I mentioned, digital representation can be quite seductive. It can easily hide problems in the design. So we need to, just don't get seduced by beautiful images. Really need to look at deeper into what is being produced. Also for schools, the frequent updates of software and hardware can be costly, and because that's what businesses do, they always have, update their program. Unless you buy it, they stop maintaining, or they stop producing, they stop distributing the software to you unless you buy the update, which means that can be quite costly. But at the same time, I guess we just have to be nimble. We need to be quite flexible about what to use, because the technology can become obsolete more quickly. So we need to be smart on choosing what platform, what software, and what hardware we should use. Finally, despite all of this, despite the great things about using digital technology, I personally believe we still need to do manual drawing, measurement. We need to still do real, not just virtual site visits, of course, after the pandemic is over, or at least you put masks and so on, but you really need to go to the site, because often if you just work in the virtual world, you don't really have that sense of scale. Going to actual construction sites, doing real construction activities are really still required to provide the sense of this reality check. And finally, although this is the great things about having digital technology, we can communicate, I can deliver this talk virtually, I believe we still need to have actual interaction, face-to-face interaction. The lesson learned from last year shows that students, at least our students, really prefer to go back to campus. And we've been back to campus since early this year with options of people to be online. But we found that the face-to-face interaction is still a lot more beneficial than simply doing things online, because I believe there's nothing that can replace real interaction, because you will really learn, social communication is so important. And so let's not forget that doing the real thing is still very important, because at the end of the day, we are training designers, architects who will work in the real world. They need to touch, they need to feel, they need to meet, they need to do things in real life. With that, I'd just like to thank you for your attention. This final image is from a student, one of our final year students who designed a human habitation in the moon. So, of course, digital technology is important, not just to represent the idea, but as you can see here, some of the drawings here are still done by hand sketches. But the great thing about this is in the moon, of course, there's limited materials that you can use to build materials. And of course, you cannot bring workers to the moon. So the idea is using digital technology, using robot to build the structure. But the great thing about this idea also is the material that will be used is actually from, let's call it brick, but the brick actually comes from the substance on the soil, quote unquote, of the moon surface. And that similar material actually currently is being tested using 3D printing techniques, in our structural lab. And so that kind of masonry type kind of material is intended to be used for this structure, where a robot or robotic arm would actually put them one on top of the other, of course, with some bonding agent and so on, to build this habitation. So yes, digital technology is here, is the future, but once again, we still need to be able to put that back into reality. Thanks, everyone. I hope you find the talk useful.
Thank you, Professor Veronica, although you are doing it in video, but it is very interesting because you start with a historical review from manual drawings in 1980s and then CAD in 1990s, and move to Rhino, Revit, Grasshopper, etc. in 2010. And that, as you just presented, changed the way we design, change how the government regulate building designs, and also change how the clients see or how the client evaluate the design of the architect. And at last, it also changed the way contractor execute buildings. They may use a very huge 3D printing to realize the design of the architect. And all of those technology changed the way we learn and teach architecture. But you also highlight some drawbacks, which is we need time to learn. It might be very costly, and it need new skills and new knowledge. And most importantly, you note that it might lead us to the loss of sense of skill and loss of sense of reality. That's why at the end of your presentation, you still highlight that we still need to touch the real world. Thank you once again, Professor Veronica. We have one question for Professor Sas, but before we go to the question, I would like to go to our third speaker for today's sessions. Our third speaker is Associate Professor Eka Sediadi Rashad. He is from the School of Engineering, Department of Architecture, American University of Ras Al Khaimah. I'm sorry if I mentioned it wrong.
It's okay.
His presentation will be best practices of digital architecture in student works. I think all three speakers have a very interesting theme to discuss, and they all relate very strong one with another. Dr. Eka has more than 25 years of experience in education related to the theory, method, scientific knowledge-based approach, and the implementation to architecture design and the site planning process. He completed his PhD study supported by the DAAD, or the German Academic Exchange Service, in 1996. I was in the beginning of my bachelor degree at that time at the Faculty of Architecture and Landscape Science at the Leibniz University of Hanover in Germany. Okay, Associate Professor Eka, time is yours.
All right, thank you very much, Mr. Moderator. Should I use my own slide shows, or can someone help me to control the slide changes?
Which one is preferable for you, Prof. Eka?
Okay, I tried to share. I have my own here.
Okay.
Just a minute. Can you see the monitor? My monitor already?
Not yet.
Not yet. Okay, just a minute. I try to. Okay, just a minute. Yeah. Share screen. How about now?
Yes.
Okay, now full show. Okay, is it
yes.
okay now?
Okay.
Okay. Okay, good. All right, so thank you very much for the opportunity to share something in this great event this morning. First, my presentation titled "The Role of Digital Architecture in Student Design Best Practices." In the preparation of this presentation, I have changed more than 3 times my my titles, because somehow there is a question which should be clarified about digital architecture or digitalization in architecture. This is the one situation. And then the second is best practices. Is it really digital architecture or digitalization in architecture will be one of the best practice for architects? And then in my materials, my presentation materials, most of them are somehow come from a daily product of students I experience here in my university. And compared to what Professor Veronica shared just now, it looks more to her history part of her presentation, because somehow what we are doing here is not as sophisticated or not as advanced as what she explained in her university. So this presentation mainly based on myself and my group as studio instructors in not only in my current university but also in my previous university. I was a couple of years in Malaysia, in University of Technology Malaysia, one of a major and prestigious university among School of Architecture, World School of Architecture. So let's see. Maybe there will be a clarification more about my two questions about the digital architecture or digitalization of architecture and the best practice. Okay. As introduction, we know all that in architecture study, design is a creative activity. It allows someone starts from a first day they join our architecture schools, is to have a freedom for them to realize or to communicate their ideas about building design or built environment design. And the main communication tools of the study is drawing. Yeah, we cannot explain much about the idea without something that can be shown to our partner, our communication partner, whether it is a building owner or the instructor of the studios in the school. Yeah, that's why I think one of the situation is to keep these drawings, regardless where or how the drawings are produced, to be to be the main, I think, to be the main communication tools to other people. And then, as Professor Veronica mentioned, we are flooded with this kind of technology, yeah, internet technology, communication technology, and especially the digital tools also in architecture. And some of the approach or the use of digital architecture are also introduced in high schools, yeah, so not merely in university. So I think in this introduction, I just want to think back that the drawing is the means of communication, and with drawing we can share, or the students architect can share their idea to other people to make them understand about what we think, about what architects think. Okay. I think I should thanks to Professor Veronica with her brief presentation about what happens in our school, in our architecture school. She has explained very detailed from one point to the other, historically also. So I think my presentation this time is just to partly will be a factual, yeah, will be showing a factual situation of what happened in our school, at least in our school. Yeah, because you know the architectural education here in UAE started later compared to our universities in School of Architectures abroad from here. So in the Western schools, Australia, or even in Asia. Yeah, they have started the education in 1970 as they had their Independence Day. Yeah, Independence Day. So we can imagine, we can think also, we can understand that the educational aspect here is somehow not as advanced as what have been done or what is going on outside the UAE. So back to the presentation here, I wrote here, the students learn to develop 2D and 3D spaces in architecture study programs to support human activities. So in this case, human will be people, human users will be the main point of the design. So not the building itself, not the tools or not the idea. Yeah, so this should be one of the things that also be kept in mind beside drawings, beside producing drawings of the ideas. Yeah, so they create the form of buildings based on the needs, function, the strength of the building structure, and the beauty of its appearance, as Professor Prasasto Satwiko mentioned in his first presentation. Yeah, so these three main points are always be our basic consideration in architecture. Okay, and this is the research methodology. I don't have any special or any special research done for this presentation, but based on my self-observation about what the students produced, yeah, about in their study period. In our school, I think the students should do stage by stage work. So it means from the easiest one until the complicated one if they reach their final year for to produce this graduation final project. But you see that the study period is limited, yeah, 5 years. So, and the materials to be taught or to be shared to the students are many things, so many. So obviously we can see that the time limitation also plays a big role in the education of architecture. So students should do exercises, producing sketches, scale drawings, creating models, doing computer simulations, as Professor Veronica explained just now, rendering and presenting the basic ideas until the final design in jury review sessions. Now I just want to share something which I think important in the architectural education. So this is in general, and it can be also relates to our topic, digital architecture, that what we think is still important is, number one, the freehand sketching. So I think we have learned, all of us who graduated from architecture schools experience this kind. So we think this is one of the situation, this is one of the skill that should be maintained. And if I understood from the previous presentation, it was mentioned also that some a sense of visualization, the idea will be supported by this skill. Yeah, so students should train themselves to visualize their ideas using sketches on paper, it can be on paper or using other tools, but the basic skills is about freehand sketching. Yeah. The second point is the course learning outcomes in each academic years. So we see here that for sure in our schools we have our syllabus and this course learning outcomes. So from first year until the fifth year until the last year of study, we have goals. Yeah, goals that students should be able to do. So looking at the stage by stage work that students should do, I think the first year will be the one of the not easy, right? One of the period where students who joined our school directly from high school, they some of them they don't know exactly, they don't know much about architecture. They sometimes surprised. They were surprised if they are asked to do this sketching. But now I think there are some tools that can help them to complete the assignments. Yeah, but the main assignment is to try or to help them to visualize their idea using the sketches. Yeah, we have this what we call it board, sketching board, then it's okay. But that is only a tool to represent the drawing. So here I just quoted some CLO or course learning outcomes that are implemented in our schools. You see that the first year students should present their design ideas in sketching, drafting, and modeling techniques. There is a course, ARCH 115, Architectural Drawing and Presentation. It introduced students to the most common 2D and 3D software, so AutoCAD, SketchUp in this case, and used in the field of architecture to create and develop graphical and technical presentation. So parallel to this CLO, they are trained also to start with the freehand sketching ability. Goes to second year, so the assignment will be more complicated, more sophisticated until the fifth year. Yeah, so the introduction of softwares are done start in the third year, so not starts from the first. The first year they are only introduced to basic tools for using digitalization in the drawing. But more sophisticated software, Revit, and the other BIM softwares are introduced later in the third year. The fourth year and fifth year is the period where the students should train themselves and choose any software they want to use for their for the visualization of their design. At the bottom, I just put two simple examples about what they have done in the third year using this parametric design approach. Yeah, and to be honest to you, this exercise is not easy. Yeah, it's not easy until to produce this kind of drawings. Yeah, because the preparation and the time where the students should master the software first, it's also takes some time. And this is some examples of our first year products. So you see it is a manual presentation of design assignments. These are freehand drawings that are done by some of our first year students. Yeah, so you see, including the modeling, the development of 3D model using a very easy, very light, easy building materials. This is to train them to know about 3D and 2D presentation. And next, you see here how the first year students trained, so to say, trained to implement their sketches, yeah, their freehand sketches to complete their design assignment. So we see that they are, some of them or most of them are happy to implement this freehand sketching skill, because they like to see their own sketch, with colors and so on. So this also one of the point that they should present at the end of the semester, yeah, relates to their design, architectural design assignment. And second year and third year, they started, the students start to use the software or application for more, so to say, not beautiful, but realistic, yeah, realistic visualization. And as Professor Veronica mentioned, on the right side, you see one of the elevation drawings, yeah, produced by software. You see, yes, she is totally right. If a student doesn't feel the real scale of the building, we can have a false understanding, and they were surprised. They are surprised if they are told that the real scale is not like their presentation in the drawing. Yeah. Okay. This is another assignment to produce a technical drawing exercise. Usually this is for construction based courses using Revit. And then, okay, so I think those are some examples that I can share with you what about some of the students' product, students' drawing products using some softwares or drawing tools application. And just a short conclusion. So number one is that, as I mentioned, architecture students should start with freehand sketches, and this should be maintained. So this is not only to give students a chance for a semester, for one semester, to train themselves about freehand sketching, and then after they pass the course, they will forget these things. We don't think this is a good habit, yeah. But they should maintain, because until 5 years, as we experience with the senior students, they still need ability to produce sketches, which of course more complicated and more sophisticated compared to the first year students. So, and then we cannot agree that they cannot produce their drawing only because their laptop or the computer have a problems. Yeah, and then the second, when introduced to the digitalization of design process, tool or software provides aids in architecture design should be able to fulfill the requirements of architecture students in start from the first stages of architectural design. So it means if there is a tool, yeah, to have to help students in producing freehand sketching, that would be fine. That would be helpful tools for them. And then, as Professor Veronica mentioned also, students need time to familiarize themselves to work with the tools and software provided. So we see only the end product of their efforts, but sometimes we forget the time about the time they need. They need to master or to know the software they need very well. And then sometimes they have a problem also in sometimes, for example, and rendering. In rendering process, some of students complain to me that Professor, we cannot do faster because we need 1 day for the rendering, or a couple of hours to finish the rendering process. Yeah, so this situation, familiarizing the students with the tools is also or should be considered in the study time, time in our school. The last point, this is just another reason that Professor Veronica mentioned also, that for the school, for our schools, the cost may be one of the important issues to provide the utilization of computer software. The price, software training, periodical development, and so on. This can make a significant change to the work systems in the design unit. So we are feeling now, we are experiencing now the situation. Outside there in the job market, in the real world of architecture, design implementation, they have done, or they have so many advanced technology, advanced tools to support their design. But in school, there is another situation. So this was at least my conclusion. Although in other previous school I've joined, they have also sophisticated tools, but somehow this, for example, periodical development or updating the software and so on, it takes time and also cost, because this is another situation. This is business. This is business. So we have to consider also this, and then this can make a significant change to the work, to our school, including ourselves. So we have to train ourselves to catch up the development or the advanced situation of the digital architecture or the digitalization of architecture. These are the reference what I have used in my paper. And before closing my share this morning, I just want to show you something. This is in Dubai. This is I put a question mark here. Is it an architecture school student's dream? So it is one of the new building. It's a museum. It's called Museum of Future in Dubai, and it is scheduled to be open on 1st January next year. Based on the information, written information, you can check also in the website from the architects, from the team that completed this kind of assignment or project. This 7-level building is one of the new building in Dubai as a product of BIM working environment. So we know BIM is one of the future working situation or working environment, which also affects architecture world. The design realization was a fully implemented of BIM design and construction process. So they try to realize this kind of building using similar process of an aircraft construction. So start from the beginning, they use BIM to communicate all the details in the building. Yeah, so compared to what we, maybe from Professor Veronica's experience, this kind of building form, this is new building form, can be one of our future architecture product. But from other schools, I'm focusing on architecture schools. Yeah, so not all of architecture schools can support the education program in their school with equipments or tools that can bring situation to students who can try, yeah, who are eager to try to develop some kind of this product. Yeah, so I think this will be a challenge. Yeah, so we are flooded by the tools, equipments, and so on in education. But I think we have to be careful and not to lose our sense, our natural sense that architecture is for humans and for a better built environment. So this is not a promotion, yeah, of this building, and because you know Dubai is one of the showcase of architectural design product of some of, I don't know, maybe most of the famous architect designs are there. Yeah, so this building will become one of the exhibition of the showcase focus in the UAE. So with this slide, I want to conclude my presentation today. Thank you very much again for the opportunity. And I should thank Professor Veronica about with her presentation, because somehow my materials, my presentation materials relate closely to what she has explained just now. Okay, thank you very much.
Thank you, Pak Eka. What an interesting presentations. It really relate 1 to 3 speakers, from speaker number 1, number 2, and number 3. Pak Eka highlight the importance of freehand. So if I relate it with what Pak Sa said, it like try to combining the left and the right brain. Yeah, we still have to train our right brain, not just our left brain. And then the tools should assist the needs of the students, and it is time that we need time to familiarize our student to use the tools. And this the matter of time asked by some of our participants in the chat box. I will tell them to ask questions directly to the speakers. And the last is cost. So the institution needs a lot of cost to invest. When we start to investing this year, next year we still need to think about the development of the technology, which require more cost. So let's go to the questions from the audience. I have question from 3 participants, from Ibu Juwarni from Itenas, Pak Heru, and Pak Doni. The first, Bu Juwarni Anita, would you like to open your mic and ask questions directly to Pak Sas or Pak Eka?
Oh, okay. Thank you.
Yes, thank you.
Okay. Thank you, Mr. Prasasto Tapiko. I want to ask you about your presentation is interesting, but some question I want to ask you, especially digital technology can reduce design creativity if the user is not technologically savvy. So it is still impossible to design buildings without digital technology now, because you said that technology crawl for art of human like that. So is it still possible to design buildings without digital technology now? And the second question, for art students, in what semester are they taught digital technology? Because they also have to be able to sketch. So Professor Eka Studiadi have explained that the second year, the first year maybe, but I don't know. But how about your opinion? Because in this institution in Internas, will the students learn digital architecture in the second year, because the first year we focus for they able to sketch for drawing. Yes. Okay. Thank you.
So, and you should I answer to Ernest directly or?
Yes, you can.
Okay, thank you. Thank you very much, Mr. Ernest,
yes.
For your questions. Yes, I don't mean to scare you, but in my presentation this morning, I was talking about digital architects. It means that in the coming future, I don't think that it's far future, our conventional profession will be replaced by autonomous robot. Yeah. So should we think or should be better by our technology? I don't think we should better, because digital architect will take over our our jobs. Yeah. Yes, I was thinking about that possibility that there will be an autonomous robot, autonomous digital architects, yeah, which will take over our conventional jobs. So we don't need what traditional method of working, yeah, because everyone's, yeah, even a layman, yeah, can just take an application and does his design by himself. Regarding the second question about the sketch, whether we are still needing to teach our students behind drawing, I'm afraid that it will be a history. For example, yeah, in the past, almost have what's it called, manual transmission. Yeah. But nowadays, there are more and more cars with automatic transmission. When you go to the driving school, they might ask you whether you should start from learning driving manual, yeah, manual transmission, car with manual transmission, or learn directly, yeah, driving car with automatic transmission. Yeah, in the future, you don't have to learn driving, how to drive, because you can buy driverless car. Yeah.
Okay.
May I share a short video? Yeah. This is from
Yes.
Elon Musk. Can you see my screen?
Yes.
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 Last April, Elon Musk with his Neuralink published this video. It's interesting that would play game. Imagine that
Oh.
there will be an application,
Yes.
yeah, so that students just think they can bypass their hands. So just think, and the computer will draw what you think. So again, I don't know if it's scary. I don't know if it's scary, but this is a technology, and it's feasible, yeah, in the coming future. Yeah. So, okay, I think that's my answer for this question.
Thank you.
Yeah.
Thank you so much, Mr. Prasasto.
Thank you.
It's very interesting.
Yes, I'm afraid that in the future we don't need to teach students how to sketch, to do hand sketch or mental sketches, because there will be a means or application or a shortcut, yeah, from our brains to the computer. So just imagine what we want to draw, and the computer, the application will do it for you.
Oh.
Okay. Yeah. So yeah. Currently, I'm preparing a theoretical base to combine architecture, psychology, and informatics engineering. Yeah. Yes, we have a small group, a psychologist, and informatic engineers. Yeah. From psychology, we will take neuroscience, and from the informatic engineering, we will take artificial intelligence. So we can combine the three of the fields. Yeah, there will be the era of autonomous architects. So we have to think another step for us, the human architects. How can we survive? Can you imagine?
Yes, yes.
Okay. Yeah.
Okay. Thank you. Thank you so much.
It's a bit scary, but yeah, we will survive. Yeah. It's just a point in the architecture. Okay, thank you.
Okay. Thank you, Mrs. Prasasto.
Okay. Shall I continue, Pak Yoman? Okay, Ibu Juarni, right?
Yes.
Yeah. So for me, somehow what Professor Prasasto mentioned is scary because I think tools or any softwares, any tools relates to architecture should have a limit. And then what we experience now, for example, architecture product, buildings, yeah. The most obvious is housing, for example. Real estates, they duplicate same design for 200, 300 houses and then sell. And also other buildings, yeah, high-rise building. We experience that some design can be constructed, can be built in more than one place, more than one site. But again, I think we have to think about architecture as a surface. Architecture as surface is one of the knowledge that serve people to support their life, to have a more comfortable, convenience life situation. And so far as I understand, is maybe Professor Pak can help me to explain more about this. Yeah. So far I know, robot or tools will act based on the information implemented in their brain in apostrophe. So outside that issues, robot can do nothing. And then in my understanding that those kind of tools until now mostly are suitable for repetition or repeated work. So continuously repeated work. So not no more than that. But as I mentioned, this is also part of business. Yeah. So we cannot reject. We have to face it, this situation. Yeah. And then using tools. I'm not saying that I'm not agree with using sophisticated tools for architecture. It's okay, but we have to think about the goals, yeah, the intention, why we are here, why we study architecture. Yeah, so not merely on focusing on how to create the buildings, but mainly how to make our user, our building user, comfortable and satisfied with what we are doing or what we design. And the second question about sketching, I just explained that in our first year, the introduction of those software are done already, but it will be more intensive in the second year. So parallel, academic year has 2 semesters. We have 2 semester academic year. So first year is totally manual sketching and so on. And the second semester, we started to introduce this kind of digitalization in architecture. So maybe in this event, the digital architecture for me is more as digitalization of architecture than digital architecture itself. Yeah, so this is what we are doing in this at the moment, Ibu Juwani.
Yes.
Thank you.
Thank you so much, Professor Eka.
Okay, thank you, Ibu Juwarni and the 2 speakers. We have interesting question from Pak Doni. But before going to Pak Doni's questions, I would like to go to Pak Heru or Ibu Heru. Could you please open your mic and share your thought, because it is related to what Pak Sas and Pak Eka just discussed just now. Please. Pak Heru or Ibu Heru, are you here? Are you in this room?
Maybe from the chat board, can read the question.
Okay, from the chat box. Is there any reason why students are better using computer or digital in the 3 years study than before?
Yes.
Okay, Pak Sas, please.
Okay. Yes, exactly. They are in the digital era. Even my grandsons are playing with digital technology. So my grandsons, enjoy playing games, and sometimes they make buildings with Minecraft or something like that. Yeah, they never touch pencil something, yeah. But yeah, they go directly to digital technology, yeah. But yes, their schools, yeah, are still teaching how to write manually, of course. But I can learn from my grandsons that they enjoy go directly to digital technology. Yeah.
Tablets, right? They have tablets.
Yeah. So even my students, my fresh students in the campus, in my opinion, they are very digital literate students. So yeah, they are more what prepared to with computer, maybe with iPad, over there with pencils and rubber. This is the millennial generation. Yeah. Yeah, maybe you, Pak Eka.
Prof. Eka, do you have any thought on that question?
Just a minute. I think it is Azan, right?
Oh,
Can
yeah.
we wait? Can we wait until it stops? It ends. Okay. Is it finished already?
Is it
Yeah.
finished?
Yeah. Okay. Just a short comment that the question was about why the drawings, right? The drawings using a computer looks much more beautiful. Okay. So I agree with that. I agree with that. That's why what I mentioned in my presentation is that the skill of creating drawings should be always maintained. We have tablets now, so our students, some of our students go to campus, visit campus only with small tablets and one small laptop. No books, no pencil, no pen. So they just use that. But we believe that this kind of tools only helps to beautify the goal, not to explain the actual idea of what the students have thought about it. Yeah. So sometimes we are pleased more to what we see compared to what is beyond that, compared to what the student thought and should explain. Yeah. So of course, a good presentation supports more about communication. Yeah, but only depends only on those tools. Is for me, it's not the first choice. It's not the first option. Yeah, because we are Pasas, all of us, most of us are not the millennium generation. We are typing machine generation. So now our children don't know about the typing machine, which sounds very loud if it is used. Yeah. So, but the art of creating sentence is the one beyond we use typing machine. So that is what I thought about it. So beautiful appearance should be, but they should have because imagine if our students depends fully on the tablet and they lost it. They don't have a skill to draw by themselves. They cannot say to the user or the building owner, sorry, sir, I cannot discuss your project today because I have to buy a new tablet. this is not the situation for us, right? So I think that's the reason why I still believe that freehand sketching, manual, natural freehand sketching ability by the students should be maintained. Thank you.
Heru, any further thought on that issue, Heru, please?
I'm sorry, I just tried to turn my mic on, but the host is a bit late. Okay, sorry, Mr. Eka, the question is about the third year study. Actually, is there any reason why specifically you mentioned about the third year study? Because I agree with you that in the first steps of the fresh students, maybe the new students, they should using sketch or drawing, hand drawing, rather than using the digital on computer. But then the question is, when should they introduce and allowed to use the digital system or the digital product? That's the problems also in my university. Actually, I'm a lecturer in Brawijaya University in architecture department, but we still have no basic research why we used to why we don't allow them during the first and second semester. We allow them in the third semester, but that's I don't have any reason for that. So is there any reason for the third year study? Actually, this is for Mr. Eka. For Ms. Veronica, if I'm not mistaken, I missed the information when the students in Adelaide Uni are allowed to using the computer system. For Ms. Veronica, I think was my question for both of them. Ms. Veronica, I've met you in Adelaide Uni. Are you still working with Terry Williamson? Thank you very much.
Any response, Pak Eka?
Yeah, Pak Heru, I think that is our current curriculum. We are thinking also about moving the introduction of this softwares, especially the software, the presentation software, and the software that can support their design scientifically. So I mean, how to, Professor Veronica mentioned about the IESVE. So we are thinking about moving this kind of software earlier, to introduce them earlier. Some of our third year students, I don't know, I think that was their self effort, self-effort to learn more about such kind of software outside the campus. They have already implemented this kind of they use some like a heat gains calculation, materialization, how the design act based on the orientation and so on. So more in a scientific aspect to support their design. That's why we are thinking to move the introduction of this, especially this kind of software, earlier. So it would be possible that in the next 2 years from now, this third year curriculum will be, some of them will be introduced earlier, not in third year again, but also in the second, maybe last semester of the second year, or even the first semester of the second year. So this is the what I think one of the development, curriculum development in our, at least in our architecture school. So it is not a fixed, it's not a fixed schedule now. So it's developed, it should be updated also. That's the situation, Pak Heru.
Okay, thank you. It is interesting that all three discussions are coming from not millennial age. That's very interesting. Okay, let us now move to wait, let me check. Pak Doni. Pak Doni Kurniawan, would you like to open your mic and ask questions directly to the speakers, please?
Thank you very much for the opportunity, Pak Gede.
Yes,
Actually,
yes,
my questions already answered by the presenters. Yeah.
Okay, but maybe you have for the talk.
Yeah. Actually, because what I want to ask is about why you choose the third semester and the start on the lower semester become manually then digitally. That's already mentioned by Pak Eka Setiadi. But we just use our curriculum as a task to make the student that you use the manually in the lower semesters, but when you go to the higher semester, so you use the digitally. There is no reasons actually because of the curriculum. There is no I think what we do right now in the digital research, we don't have any clue about that ones, because we already know that our student already technology savvy actually from preliminary schools until the high schools right now. And when they have the manuals to sketch, so there is no, I think there is no reasons when we give them the task to have a sketch in the lower levels. So that's why I want to ask about that one. What's the reasons when you mention, especially maybe this is experience from another country, Pak Eka Setiadi, about why you just choose the lower level to do the manually than the digitally, because they already know about the digitals. So that's my point about these ones. And we know that we have limited times around learn architectures. So it's very difficult to know about the structures, all of the structures of the system of the structures, all of the system of utility or building performance. And right now it's very difficult to deliver all of the items that we have to mention to the students. So this is this is our task in the future actually. So that's my questions, Pak.
Okay. Any thought, Pak Eka or Pak Sas, please?
Eka,
Yeah.
of course, Pak Eka.
Okay.
I want my students to start from the first K. In my university, doing digital analysis.
Okay, just nice to meet you again, Pak Doni, after a long time. Okay, so as I mentioned, the education system here started much later than what happened outside the UAE. Yeah, so I joined the school in 2017. So the curriculum now is already a bit advanced before then compared to the one that we had the last 5 years. So I'm sure that digitalization will affect the situation here. Yeah. What happened here is that what is happening now, at least in UAE, there are more or not more. There are many foreign universities open their branch here. Yeah, so they bring their own lecture from their home country to teach the students here in the UAE. So this kind of situation, my situation of my university is also not is open. It is established in 2009, so it is relatively young. So all the curriculum and so on, just so to say, not imitate, but try to consider based on what happens outside. Yeah. So the effect or the effect of digitalization will come, but we have, so this is administrative situation. So we cannot change the curriculum following what happened outside just like that, because we have just renewed our accreditation, and it took 2 years for that. Yeah, so you can see how this administrative steps, so to say, to be followed. Yeah, but based on the situation that foreign universities are here, so the government here can see the discrepancy between the local university and the foreign university, and old university and new universities. Yeah, so we consider that the effect of the digitalization will continue. Yeah, but as I thought about, as myself think about this manual sketching and so on, I think this is one of the skill that should be maintained. So I mean, maybe just in the first semester, accompanying parallel with the so to say sophisticated drawing tools and manual drawing tools would be a situation that support their study. And as you mentioned, there are more softwares related to non-architectural, non-artistical aspect. They are more about scientific things, research, and so on, right? So this is the situation, and this actually those are not architecture. Those things support architecture. But now somehow the world moving to that direction. Yeah, as we have discussed, maybe experienced in other events. For example, we have to jump to another house, so to say, in apostrophe, to learn more there, and then come back to architecture. Use the knowledge that we have learned from the other house to be implemented in our own house. Yeah, so this is the thing that I still believe that artistical thing should be maintained there, because there are some report that digitalization cannot support fully this aspect. Yeah. Okay, so maybe that is one of our, so to say, our belief, our belief until now, and the one that we are doing now. I hope this answer your question, Pak Doni. Maybe Pak Sas have some another point of view. Okay, thank you.
Any thought, Pak Sas?
Yeah, it is a continuous discussion, I think, about the importance of hand sketching. I think this is the transition era. Yeah, transition era. To move from sketching to fully digital sketching or something like that. Yeah. Long time ago, when we went to music school, we had to learn scale first, not melody. Yeah. But now when we go to music school, we can jump directly in front of keyboard and play music. Yeah. So the teachers seems motivated by teaching their student how to read scale or dialogue. Yeah. I think this is a good analogy for in the architecture education. Yeah. And I'm sure that we are in the transition era. Yeah. There are still many lecturers who are still having romanticism, like we are, Pak Eka, working with manual typewriters with noisy bell, ding, ding, ding. But yeah, our students don't have, our new students, our students now don't have that kind of experience. Yeah. They go directly to the keyboards. Yeah. It's a transition era. And I would say that we should be prepared, yeah, well prepared. The incoming full digital era.
Yeah.
Otherwise, if we don't, if we don't teach students how to prepare to face that disrupting era, we will lost,
Yeah.
we will lost the fightings. Okay, I think that's my conclusion.
Maybe I can add something also that.
Okay, please.
The curriculum itself, it has a limitation, many limitations. Yeah, if we want to put all the things inside the curriculum, maybe architecture study program should be taught longer than 5 years. Then from the business point of view, so you see, now universities, somehow, some universities are acting like a business. Yeah, so from the business point of view, this is not, it doesn't support this kind of philosophy. Yeah, so keeping the basic thing in architecture, I think we should keep that. Yeah, so not just follow the development of the advance of this the rapid development of technology. Yeah, because again we are serving human. Yeah, we are serving human, so we have to put this consideration as a basic situation. I know some of architecture consultant here. They even use this what is this virtual
headset.
camera, right? So here in UAE, so compared to what I thought, very conventional, very historical situation, yeah. But during the discussion, yeah, using pen, using virtual presentation, this kind of human to human touch, human to humans feeling, and so on, still happen. So a repetition of design here in architecture, actually, I'm not fully agree with repetition. Design, yeah, design repetition. It should be tailor-made based on the need. Yeah, and yeah, I know, like I've showed just now at the end of my slides, this museum of the future. Yeah, it came from the ruler in UAE. So the idea came from that person. Contact the architects. I want to have this kind of building. So we cannot see that the architect's team cannot say, oh, so sir, we cannot do that because it is not our expertise, right? So then they have tried. That's why they try to fully use BIM for the process and imitate the aircraft construction process. Start from the construction structure, building structure, building materials. Even if you see the outside, the facade building, this is aluminum steel which is used for aircraft. Yeah, so this is the situation. But again, we serve humans, so we cannot just accept a fully digitalization period. Yeah. Thank you.
Okay, thank you for both speakers and also Pak Doni, Pak Heru, Ibu Anita for your questions. We are now approaching the end of the sessions, so I will make small conclusions because the discussion is quite big. The first is digitalization is taking place in architecture, and this process may lead us to digital architecture. And we in the education field, we are still working on this issue and keep thinking on how to or what is best to include in our curriculum. Thank you for all speakers, and I will pass the session to the.
Thank you.
Thank you.
Thank you.
Thank you, Pak Eka.
Thank you, Pak Sas. Thank you, Pak Gede.
Okay, thank you, Mr. Newman, Prof. Prasasto, Prof. Veronica, and Mr. Lukas. Thank you for the great presentations and discussion. Ladies and gentlemen, the first discussion has ended. We will continue to the next discussion at 1 p.m. GMT +7. And now we have around 30 minutes break. Thank you. Okay, once again, I would like to
Remind you that we have around 1 hour break, so we will meet again at 1 p.m. WIB or GMT +7. Thank you.
audience. For the first sessions, we will have question and answer session directly to Mr. Fukuda description, since professor will have another meeting. So please also prepare your question after his presentation. Let me read his short CV. Associate Professor Fukuda, he is an expert in environmental design and information technology. He develops new environmental design methodologies which can organize the relationship of humans, artificial objects, and nature systematically, deploy advanced information and communication technologies, and create new environment when ICT embedded. He also has experiences on Work 16 VR Research Group, studied in Osaka University since bachelor, master course until doctoral course. Now, he is a president of CAADRIA, the Association for Computer-Aided Architectural Research for Asia, and professional membership of Education and Research Association, Computer-Aided Architectural Design in Europe, Japan Society of Civil Engineer, the City Planning Institute Japan, and many more. Let us welcome Associate Professor Tomohiro Fukuda. The virtual space is yours.
Okay, thank you very much. Okay, can you hear me?
Oh. Yes, Sensei.
Okay. Okay, thank you for coming. I'm joined from the Osaka, Japan. So my name is Tomohiro Fukuda, Graduate School of Engineering, Osaka University. So today I talk about technological development of digital architecture. So let's begin. So let me introduce our laboratory. The laboratory at Osaka University is in the traditional Japanese style and consists of 2 faculty members, Professor Ebuki and myself, and more than 30 students in the doctoral, master's, and 4th-year undergraduate programs from over the world, in addition to domestic in Japan. My research area is environmental design and advanced information technology. With the aim of construction super smart society, I'm researching the application of advanced information and communication technologies, especially XR, virtual, augmented, and mixed reality, building information modeling, BIM, artificial intelligence, AI, and Internet of Things, IoT, to architecture, civil engineering, environment, and urban engineering. Our research aims to solve the problems of society by balancing theory and practice. The life cycle of a facility typically involves non-professionals, such as local residents and citizens, and professionals, such as owners, architects, and administrators. It is important that these various roles understand to design contents presented to them, consider the various perspectives, build consensus, and move the process forward. A variety of media and tools have been developed to communicate to others and build a consensus in the process. Recently, the design and construction process of developing facilities has become more sophisticated and complex, and the number of stakeholders has increased. As a result, there's a need for further tools that can better reflect the thoughts of the participants themselves and allow them to more intuitively consider what they want to know in a virtual space. So I remove my camera. So virtual reality, VR, is a term coined by Linear, augmented reality, AR, by Cordell, and mixed reality, MR, by Milgram and Kishino. Also, diminished reality was coined by Mann in the concept of mediated reality, including AR, MR, and DR. So then we introduce our recent topics. The first one is the application of mixed reality to landscape simulation. Recently, we will integrate mixed reality and artificial intelligence. For new landscape review, a photomontage is usually created by composing a virtual design model into a photograph of the current situation. but it's a still image. With real-time video, you can change your point of view and handle moving objects at will. How do we create this plan with mixed reality, that interactive and real-time video montage? So our methodology. This is an old buildings in its current state. The plan is to demolish these buildings and build a new structure. First, mask the area of the old buildings. The next, the area is filled with a pure green color that doesn't exist in reality. Next, the filled area is made transparent and instead, the visible background is painted. Then the new structure is drawn in the appropriate place. However, in this state, the relationship between the structure and the trees in the foreground is not correct. So then the foreground area of the tree is extracted and painted at the end. These processes need to be automatic and fast. To achieve this concept, the current structure is virtually erased and the new 3D model is synthesized. In other words, we are dealing with both diminished reality and augmented reality. We will refer to this as mixed reality. We have been developing mixed reality step by step over the last few years to make this happen. As core technologies, we apply game engines, image processing, structure from motion, and most recently, deep learning. Let me explain them in order. This diagram shows the definition of the 3D models on the game engine. The green buildings in the center in the mask model for virtual demolition. The newly constructed buildings is modeled by building information modeling software and imported into the game engine. The background model and occlusion model, such as trees in front, were created in advance in structure from motion, photogrammetry in other words. This is an explanation of the mask processing in the case of offline movie. Except for the persons to be composited by computer graphics, it is taken as a green background that don't exist in the real world. Then the people are combined with another computer graphics except for the green color. This is a result at 2018, 3 years ago. This system enabled us to examine the current status, the future landscape after the new construction, extracted images of green areas by image processing, and estimated green view index simultaneously. The red and blue dots and yellow lines in the current video show the tracking reference points of mixed reality. The value at the top right shows the current and planned green view index. However, challenges remained at that time. One is occlusion to objects that appear suddenly during mixed reality, such as moving people, cars, and trees cannot be handled dynamically. Therefore, we came up with the idea of incorporating AI deep learning into mixed reality. This system extracts masks and virtually eliminates moving people and cars that suddenly appear in real time while mixed reality is running. The upper left is a current live video and the lower left is a masked video. Buildings that do not move during MR are predefined by structure from motion. Moving people are masked in real time by deep learning object detection. The right is a diminished reality output in which motionless buildings and moving person are simultaneously and virtually deleted. But in this step, the people object are extracted as a rectangle, bounding box. As a next step, we adopted a semantic segmentation technique of deep learning to handle occlusion dynamically with outlines in outdoor mixed reality visualization. Semantic segmentation can extract each object region pixel by pixel. Thus, dynamic occlusion handling can be realized using this technique. Real-time semantic segmentation involves heavy processing and thus requires high-end desktop computers. However, a proposed system is to be used for landscape simulation outdoors, so it needs to be used on the mobile device. Therefore, we developed a system in which a client device transfers image frames frame by frame to a server via internet, which performs semantic segmentation processing on those frames and sends proceed frame back to the client. The result shows that developed mixed reality system can transfer the webcam frames to a server computer with video communication over the internet, and the server computer implemented semantic segmentation processing on every frame and sent it to the client. Then dynamic occlusion handling was realized. The top left is a live video of the current situation from the laboratory, and the middle left is a segmentation video. In this case, the fence video is categorized into sky, buildings, and tree and fences. The bottom left is a masked video that defines tree and fences. These are defined as a being in front of the 3D virtual model. On the right is an MR image of the real world tree and fence that has been occluded through these processes. This dynamic occlusion handling helps to conduct more appropriate MR-based landscape simulations. However, semantic segmentation is not able to distinguish between the different objects of the same type. Then we developed a new mixed reality that enables the recognition of each physical object individually using instance segmentation. And it's possible to accurately represent the potential positional relationship by comparing the coordinate information of the 3D virtual model and all physical objects. This is a visualization image of mixed reality. The new medium design for road. Using cars as a target of instance segmentation, we are able to place a 3D virtual model behind the car traveling to the left of the screen and in front of the car traveling to the right. You can see that the system can identify physical objects of the same type even under occlusion. This is another new trial. We developed an AR and drone integrated landscape visualization method to handle occlusion by linking the drone's location information in the real world and the camera in the virtual world, like a city digital twin. The method uses a 3D model of the existing buildings, which is part of the city model, to represent a 3D model of the design target as if the target was behind the existing buildings in the real world. Users can use the perspective of the drone, which flies along a set route, and to examine the future landscape with high accuracy as visualized using AR with occlusion handling. As I told before, diminished reality have been proposed to visualize the future landscape after the structures are removed. However, two issues remain to be addressed in previous studies. First is the user needs to prepare 3D models of the structure to be removed and the background structure to be rendered after removal as pre-processing. Second one is the user needs to specify the structure to be removed in advance. Therefore, in this study, we propose the DR method that detects the object to be removed using semantic segmentation automatically and completes the removal area using generative adversarial networks we call GAN. Using this method, virtual removal can be performed without preparing 3D models in advance and without specifying the removal target in advance. As you can see, prototype system was developed that the method can represent the future landscape after removal. The next topic is the integration of architecture planning and environmental design using XR in the early design phase. So we developed a workflow that integrates BIM and computer fluid dynamics, CFD, and XR to display the result of CFD calculations as they are. MR allows us to visualize current thermal environment simulations and conduct renovation design studies on site. We use HoloLens as an optical see-through head-mount display. The video above shows the experiments of the user wearing the HoloLens, and the video below shows the CFD result as seen by the MR user. CFD animation is a loop. The streamlines are representative of the airflow, with red indicated warmer temperatures and the blue indicated cooler temperatures that indicate the winter condition in Japan. It also shows a thermal simulation of a room divided by two new participant walls. The real space and virtual models of the partitions and CFD simulations result are corresponding to the occlusion. It uses voice recognition as an interface. When the CFD results are displayed at full scale, it's easy to intuitively understand the thermal environment, but it's difficult to understand the whole picture of the room. So if the user says small, it will be displayed on the reduced scale, just like a physical model. You can also use voice recognition to switch between the current state and proposed design. This is another application using a head-mount display HoloLens. This is DR, which is a VR virtual erasure. Oh, okay, I see. I checked the chat box. Is represented in the live video using 360-degree live streaming instead of creating a 3D model in structure from motion as before. So this movie on the left is a scene that the user sees through the head-mount display HoloLens, and the movie on the right is a real-world view in the student room of our laboratory. The MR user can see the walls being virtually erased and the next room as if they were looking through the live streamed perspective. Occlusion between the real and virtual world is also achieved, although it affects the accuracy of the meshes HoloLens generates. This is the last part. On another XR topic for collaboration. In 2006, 15 years ago, I came across a physical exhibit called Future Meeting Style at Venice Biennale at Italy. The idea was that some attendees would participate face-to-face while others would join the meeting online. This year, due to COVID-19, this kind of meeting style is not uncommon like today. Then I tried to figure out how to share 3D information needed for architectural design study online. 10 years ago, as part of Ministry of Economy, Trade and Industry Japan project, Forum8 company and I developed a cloud-based VR and evaluated. This kind of system for sharing 3D digital models online has now become common in building information modeling software and services and virtual reality software and services. However, it requires special application software and not apply to the mixed reality. Then we developed 3D remote sharing system of the real object using real-time point cloud on mixed reality. Our system generates both sender and the city model as real-time point cloud using RGBD camera. D means a depth. A receiver who is in a remote place wear the HoloLens to participate sender's presentation while handling 3D models. Since the city model put on a desk was also placed on the receiver's side. Positions were aligned as if the scale model was on this desk. So this is a view from the receiver wearing MR HoloLens. The receiver could freely move about the meeting room and understand the sender's movement and the scale model by real-time point cloud. When the receiver moved, the appearance of sender and scale model changed from the receiver's viewpoint in real time, which is impossible by 2D display such as the video conference room like Zoom today. However, the real-time point cloud was transferred as a single object at this project, and the receiver could not manipulate each object. For example, the receiver could not manipulate only the physical model. Also, it was not possible for multiple MR users to share the high-speed point cloud. So we are working on further development. So this is the further development of our recent achievement. We have already implemented several features that solve the previous issues. The first is that this, you can see this video, is a collision detection with the viewpoint cursor by meshing the real space using SLAM. SLAM means the simultaneous localization and mapping. And second one is, as you can see, the receiver can dynamically observe the assembly of the building block model by the sender, like this. The third one, as you can see later, the receiver can assemble the virtual building block model and place it on a real plane. However, this method of real-time point cloud segmentation is based on the distance between point clouds. The hypothesis is that point clouds that are close to each other are the same object. Therefore, if different objects are close to each other, for example, if the user touches the model, they will be perceived as the same object. So this is the new method is under development by instance segmentation. First, segment the acquired RGB image and obtain the pixel information of the object region from it. Then a point cloud is created from the segmented RGB image and the depth image. After that, the RGB data and coordinate data of the object region are obtained. So this is the final slide. We are not only conducting research in our laboratory, but also collaborating with governments and companies to put our research results to practical use. Finally, this is a movie that we made a few years ago using virtual reality to represent the renewal of Mizuki Shigeru Road in Sakaimina City, Tottori Prefecture, Japan. Using VR, a new Mizuki Shigeru Road was completed through consensus buildings with the stakeholders. Right now, it is difficult for me to visit other countries, for you to visit other countries due to COVID-19, but I hope you will come back to visit Japan to near future. So far, we have introduced some of the technological development in digital architecture, especially XR. The development of digital technology is remarkable, but with the pandemic of COVID-19, we expect the pace of development is increased. However, it is the human being who makes the final decision based on the digital technology and data. For this reason, we humans must also growing up. Thank you for your attention, and contribute our research. Thank you very much.
Thank you, Fukuda Sensei, for your insightful presentation shared with us today. Yes, we have a question from Ms. Nisa from Universitas Atmajaya, Yogyakarta. I will read for you, Professor Fukuda. Thank you very much for your interesting presentation. You have explained very well on how this technology can contribute to better visualization for the user to the development. Is there any case related to your major, the utilization or application of this technology as a control to the development, for the example, in cultural heritage area? So she is asking related to the heritage area. Please,
Thank you very much.
Sensei.
Yes. Okay. It's from the
Miss Nisa.
Oh yeah, Kyle Nisa. Yes. Thank you very much, Dr. Kyle Nisa. Yes. Of course. As you may know, Japan has some preservation area, and also under the landscape law, the area of the cultural heritage area should be preserved. But due to the economical development issues, some surrounding area will be developed high-rise buildings is a plan. So we are very increasing use so assessment, landscape assessment before the construction stage using the not only the photomontage but also some XR technologies, especially for the virtual reality is very useful for in the last 20 years. Of course, ongoing. And also, but the virtual reality, only virtual reality apply for the virtual environment in the meeting place. So to more higher impact to the construction site, so we try to apply to mixed reality for outdoors to check the high impact or low impact to the cultural heritage remaining. Can you hear me?
Yes, Dr. Nisa, do you have
Thank you.
any question or question more addition to a previous question?
No, thank you very much, Professor Fukuda. It's very clear.
Okay, thank you very much,
I
Professor.
got
Yes?
another questions from Jiran Baki.
Yes, from
yes.
Universitas Media
Can
Nusantara. Yes,
I
please.
answer?
Yes, please.
Okay. Okay. Thank you for your questions. Yes. How to spread the platform of the MR to the public? Your question I understand. So yeah, recently, yeah, AR and the MR and the VR is to be a kind of the democratic tools to understand what the city changes. So I think due to the some limitation of the special AR application toolkit, such as the AR kit for only the Mac and AR core for only the Google. But recently, web-based AR that the user can experience the augmented reality on the web browser, such as the Chrome. So it's more convenient for all the users can explain what the city changes. It's more, and also the platform, not only the computer, personal computer, and also tablet or the smartphone. So we tried already to develop the web-based AR on the smartphone to experience the future or the past landscapes of the cultural heritage or the future development.
So, Mr. Girlam, do you want to add some question, please?
Yeah. Thank you very much for the answer. So for the final result, it is published using the WebXR technology. Is it correct?
Yes.
I see. Okay, thank you for the answer.
So yeah, some of my presentation contents is already open to the public via YouTube or papers already.
Thank you.
Yeah.
I will read it further.
Thank you very much, Mr. Gilang, for the question. Thank you very much, Mr. Tomohiro Fukuda, for the answer. So we have run our limit of time. So this is the end of the session of Fukuda Sensei. So we will move to the second session. Okay, ladies and gentlemen, coming up next, allow me to invite our distinguished guest, Professor Insinyur Joko Budianto, Master of Engineering Philosophical Doctor from Universitas Atma Jaya, Yogyakarta. Let me read his CV. Professor Joko Budianto Setiohadi is an informatics professor and also head of informatics department at Universitas Atma Jaya, Yogyakarta, School of Industrial Technology. He holds his doctoral degree from University Kebangsaan Malaysia, and he has a lot of research projects in data engineering, information system, human-computer interaction. Professor Joko will deliver his talk about the theme of artificial intelligence for the future architecture. So, ladies and gentlemen, please welcome Professor Joko Budianto.
Thanks for the time. I will share my screen. Okay. Is this okay? Oh. Okay. Okay. Firstly, thanks to organizers. I'm very honored since I am not an architect. I am a computer scientist, and I don't know why our friend offered to present as a speaker panel here, but I really happy to discuss something which may be useful for us for the next collaboration, especially between computer scientists and architect on the future.
Yes.
And also focus on my presentation is focused on AI. So what we can do, especially in this presentation when we collaborate, any architecture with me. So my title is Artificial Intelligence for the Future Architecture, especially on the AI, especially on the data engineering or data scientist.
Excuse me, Professor. Would you
Yes.
mind sharing one more time the slides? Because we only see the dark screen on the Zoom meeting screen. Yes. Maybe stop the share screen and then share again one more time.
Okay.
Okay.
It is
Yes.
good?
Yes, that's good. Thank
Okay,
you very
thank
much,
you.
Professor.
Okay, thank you. Okay. Okay, maybe I will start by the question what will be in the future. As we know that many services in any department, any organization are performed by computer-based system, whether they use AI or not. But an example for the future, the economists predict that about almost 50% the work, the job will be done by robots. It is, I believe that it can be. And also that 90% of engineers will lose their job since AI will take over of the design process. We are happy or not, but it's also a question that can be happens. But for maybe for another engineer is do not unhappy news, but for us this is our job. Okay, so so maybe we should back to the previous to the story, and that's why I have a potential for the many application, many problem solving in the future. AI, firstly, introduced by Alan Turing, he said that actually human thinking process is look like a mechanical process. So when we able to detect, to understand in detail that, then we can implement AI in machine. So what Alan Turing do is maybe it's very different with computer right now, since they use analog computer, but now it's digital computer, and we have a big jump, I think, a big solution. And now the important thing also is that now we have big data as a consequence as in information area. Why? We know that we can learn if my knowledge is when we reach more, then we will have knowledge more. It is similar with AI. So when we have more data, we will have more knowledge also, more valid knowledge also. And we can see that until now, the application of artificial intelligence is fruitful in many areas, many industries. Almost all use AI. Maybe you want to know how fast AI was developed. Anyone ever hear that Facebook ever shut down two of robot AI names Alice and Bob? Facebook shut down of their robot since they started to talking each other in language they made. So for me, as a computer scientist, it is surprise also. So sometimes we never think that our algorithm, our system, our program can learn more than we can predict. Something like what in Facebook done. I mean, Facebook then shut down. I don't know in detail since the information is not open clearly. We just understand that two robot is shut down because of their action. So when we talk in architecture design, unfortunately, Professor and I discuss together and supervise together. When I try to study more, I have at least two challenges, which is useful, I think, for us to understand. First, that conceptual architectural design is a complex process. That's why, like I said, an expert is commonly they have more time in their area. I mean, the graduate will be different with the graduate which have more experience in design and anything. So we can say that past experience is about knowledge, I think, and creativity is also developed based on the experience, based on this knowledge. And the second is that architecture does not provide a single correct answer. It means that sometimes accidentally also, right now I try to design our new house. Then in the first stage, we meet more than one time, at least 3 or 4 times. We just discuss. Since she said that my architect is a woman, she said that they want to understand what exactly we want about our house. She tried to give me more multiple draft of drawing. I don't know what's the name in architects, but it can be said that there are many answers, there are many solutions based on the same spatial problem. So if we read many papers, and especially in the use of machine learning in architect also, commonly they use as a generator and the discriminator. First is that they prepare the training set and they try to train the machine learning algorithm in order to capture to acquire the knowledge which can be used for image assemblies, and then they can also use for the discriminator. It means that we can recognize by using knowledge which already embedded in the machine learning to make a distinguish with it. This is correct or not, or something like that. So after we discuss more, that we have the potential problem when we use AI on architect is that since in architect the problem solving is divergent. So the first problem is that when we should provide, when we should give an enough data set. Since as I said before, that many data set will be good, will be covered in anything, I think. So it is difficult to us to give, to prepare the appropriate or suitable data set in order to train the algorithm of machine learning. And the second is that sometimes in architect, we require abductive reasoning, which is a little bit different. Commonly in engineering, we use inductive or deductive reasoning. So we should accommodate that process on the machine learning when we should make a decision for the problem which is given. So the alternative solution which currently done by previous research is that first they try to generating a suitable motivation. It means that they make an example and they make many picture, many draw, many things in order to and then they try. So I think and in computer science it is difficult since the capacity of machine is limited. So many computer science try to avoid this approach. And the second is they try to accommodate the new knowledge in order to generate maybe the new design or something like that by adding data or by adding knowledge from the outside data training set. So in this case, the name is, I gave the name as knowledge injection stage. We propose like that since I think it's common when we use expert judgment in order to deal with time and cost. As we know that when we prepare and customizing machine learning, it will be timely and costly. So it is easier when the expert judgment, the knowledge from expert judgment is injected directly and can be used to make a shortcut about time and cost and anything. And also, it is easier in real world. An example, when we supervise a student, an example, after they give something to us, then we give any command, knowledge as a command, or command as a knowledge, then since the representation of knowledge is similar, then they will easier to understand and to apply the knowledge into their design. But in computer system, it will be difficult. Why? Since the storage, the representation of knowledge in machine learning a little bit different with our representation. So let me explain by our case how knowledge injection can be performed. Accidentally, 4 months ago, Prof. Sas and I supervised the student. They want to mix. They want to make research in pattern recognition area. What they want to do is that they want to make a system, program, application, which able to recognize that this is Japanese use or not, something like that. And then I said to them that, okay, that's good. You can use pattern recognition, especially also on feature extraction to deal with your cases. Based on our discussion, then we have an idea how to rebuild after they have the feature of the image to be an original image, something like that. So we try to study about how image computation can be performed. At least we find that there are two steps. First is skin generation, and the second is skin refinement. So in the first, as I said before, as I explained before, that feature extraction is easier. It can be performed right now. It's okay. Many algorithms can be developed perfectly and have a good result. And as I said before, that when we try reboot again, I said as a sketch area, so we have a problem that's relation among components by using machine learning and feature extraction are not described clearly. So an example, we have Molo, we have Under, we have Keganja, but I don't know how they can be connected each other. So sketching is need what I said before, that the relation among objects should be defined clearly. So we can repeat if we do not, we do not have a relationship among object clearly. We can also make a new one if we do not have the rule about how to relate among object, which is already decomposed by using pattern recognition and feature recognition. So what we started is, first, can we make generating image based on some rule which already known by an expert. I try to study from Liu. Then I think it can be opportunity to build a sketch based on the component which already decomposed by using pattern recognition and feature recognition. An example, we can add in our slide, we can add some knowledge sample like that. A small rat metal cylinder below a small green rubber cube. Then after it is generated input and also the interaction, we can generate the new image based on input and the interaction as described before. And also, it can be also applied when we try to edit the skin to follow our rule based on the relationship among objects. Since not all knowledge about relation among objects can be acquired by using machine learning. It is fastly when we ask to the expert and we inject it in the system. But it's still, we will study about that. But what we want to show that we have an opportunity to do like that we can make a sketch based on the component which already decomposed by using this approach. And in the future opportunity, then right now maybe even the data set is many, it's about 50,000 pair of images, but it's still not enough. We need also another approach computation, such as affective computing, pervasive computing, and anything. But we believe that more law is, in informatics we have more law that the change is exponentially. An example is simple neural network, perceptron as a simple neural network introduced by Roosevelt in 1960, then will grow up until as a deep learning. It's amazing for us. So in our imagination, the future is that any sketching can be developed only by training the system. An example, by using deep neural network and adding some user requirement. Of course, we can add the knowledge, the additional knowledge by experts judgment or by another computer in order to make some sketching to in order to give you as a user requirement what the user want to get. And I think it's enough. Thanks for your attention.
Thank you very much, Professor Joko Budianto, for your valuable knowledge and immersive ideas. Well, dear audience, save your question after the next presenter. We are directly to the next keynote speaker. Yes, we have got Mr. Muhammad Asri for the third presenter, who is now right over here with us to be our next speaker. And it's not gonna be a futuristic idea talk, but more into sharpening our horizon through an advanced perspective from the digital scientist. Please welcome Mr. Muhammad Asri. He is a computer architect, research scientist at Facebook. He held his doctoral degree from University of Texas at Austin, 2020. Hello, good day to you, Mr. Muhammad Asri.
Hello, everyone. Pleasure to be here.
Yes, so this session will be a talk show style session. So I will ask several questions to Mr. Muhammad Asri. Mr. Asri, would you mind telling us about yourself and current activities you are handling at Facebook right now? What ongoing application or hype things associated with AR, VR, and AI under the advancement on Facebook?
Yeah, sure. Hi, everyone. It's great to be here with all wonderful speakers and audience. My name is Muhammad Asri. I went to school actually for my undergrad in Japan. I first went to Osaka University to study my Japanese, the same university where Professor Fukuda is from. And later I moved to Tokyo and enrolled in Tokyo Institute of Technology. And I did the computer science major over there. Soon after I finished my degree in Tokyo Tech, and I continue my education journey to the US. I did my PhD over there at the University of Texas at Austin, especially doing hardware and software co-design for machine learning. Basically, I'm trying to optimize the machine learning application from both software and hardware perspective. Then after graduation, I joined Facebook Reality Labs, where I do a lot of fun stuff related to AR, VR, and AI. Still very relevant to my PhD thesis. It's all about optimizing the software, what the software can do and what the hardware can deliver. And we try to optimize across layers from software to hardware. In Facebook, as you guys might have heard already before, we are highly focusing on the next set of digital platform, of which we call Metaverse. In Metaverse, basically envision that people can have a next level of interaction, immersive experience to connect with their loved ones and have more immersive experience than any existing tools can provide today. And part of it is to provide new devices that could be used practically in our daily lives that would replace our existing smartphones. And imagine that in order to provide those kind of experiences, you basically have to have a supercomputer attached in your device, be it AR glasses or some Oculus devices. The challenge is that we don't have flexibility or the luxury of doing that in servers, which are very powerful. These devices mostly are battery powered, and they are very, very limited in terms of battery and energy consumption. So on one hand, you have one requirement that you have to have a supercomputer to provide with this AR and VR experience. But on the other hand, you have a very limited battery powered device. And these things don't go hand in hand. in fact, they're very conflicting requirements. So how do you go about providing immersive experience that requires a lot of computational power and energy consumption, while at the same time go about a very limited battery powered device and energy consumption? And I found that challenge is very, very interesting. And we in Facebook Reality Labs are working hard every day to aim for that goals and mission. I think that's kind of the introductory overview of what we're doing here in Facebook Reality Labs. Thank you.
Yes, thank you very much for the impressive description. And how is the battery right now? Do you already have the solution?
Well, the product is supposed to be launched in the next couple of years. So we don't have the existing product yet, because we expect this to be launched in the next couple of years.
Okay.
But we do have prototype internally. Unfortunately, I cannot share more due to the NDA, but yes, we do have that internally.
Yes, it's okay. Mr. Asri, do you have any videos so that can lead us to some imagining experience, what you have there?
Yeah, I could actually share some. Yeah,
I would
sure.
love to. And I
can
think
share
the
some video
participant
from
will like
Reality
to.
Labs. Yeah, let me share my screen really quick. All right, can you guys see my screen?
Yes, perfect.
Okay, great. So this is a video from our labs, the Facebook Reality Labs, just kind of like to introduce what we've been up to and then what sort of cool things that we're doing. I'm gonna play the video real quick.
With AR devices, we're asking the question, how do we build a computing platform that's truly human-centric? Facebook Reality Labs is a pillar of Facebook that's dedicated to bringing AR and VR to people, to us, to consumers of the world.
Every single new computing era requires new input devices, the set of interactions that really make this possible.
With AR glasses, I think the key here is to communicate with our computers in a way that is intuitive and entirely new. The wrist is a great starting point for us technologically because it opens up new and dynamic forms of control. This is where some of our core technologies like EMG come into play.
Neural interfaces, when they work right, and we still have a lot of work to go here, feel like magic.
So if you send a control to your muscle saying, I want to move my finger, it starts in your brain, it goes down your spine through motor neurons, and this is an electrical signal. So you should be able to grab that electrical signal on the muscle and say, oh, okay, the user wants to move the finger.
What is it like to feel like pushing a button without actually pushing it? That could be as simple as, hey, I just want to move this cursor up or move it left. Well, normally I would do that by actually moving. But here, you're able to move that cursor left. And it's because you and a machine agreed which neurons mean left and which neurons mean right. You're in this constant conversation with the machine.
This new form of control, it requires us to build an interface that adapts to you and your environment. The intelligent click is the ability to do these highly contextual actions in a very low friction manner.
It's kind of the purest form of superpower. You're in control, but the system is exactly inferring the right thing for you to control. All you have to do to operate it is just click.
So for example, if I'm cooking and I'm kind of pulling some noodles out of a box, the interface could ask me, would you like to start boiling the water? The risk can also be a spot where the technology is communicating back to the user.
The haptics, the sensation of touch around us. This is part of how we learn and use motor control. It's critical to AR and XR.
We wonder, as you pull back the bowstring on a bow, if we tied that not to the tension growing on people's fingers, but rather squeezing on the wrist, would it add to that experience like you're pulling back the bowstring? The answer is yes.
That future, it really is the computer that is seamlessly integrated into your day-to-day life. The next computing platform is the mixed reality platform, the one that really totally blends your virtual environment and your real environment in a seamless way.
we're in this moment where we can move from personal computing to personalized computing.
What if you and a computer agreed to design a keyboard together and you type faster on it than anybody else in the world could type on your keyboard?
I think what this enables is the ability to not have to focus on a computer and phone and be able to still interact with the open up a new generation of communication, access, and navigation.
It's this phenomenon of increased agency, of you feeling like a level of control you've never had before. You want computing experiences where the human is the absolute center of your experience.
Do you want to make $1,000 today and then $1,000 a day?
Yes, thank you
All right.
very much for the video. Yes,
I
we
hope,
will.
I hope that wakes people up if they feel sleepy this afternoon.
Okay, thank you very much. We will continue and related it to the architecture. Yes, I want to ask more also about the metaverse. Facebook also developing it right now, and whether in the future the architect, I think, will be able to take the part, whether this virtual world can develop and will replace our life experience, I think. What are the challenges and the opportunities that can be explored? What do you think? How should an architect prepare himself or herself to join in and will have an opportunities in many metaverse that are predicted to emerge? What do you think?
I think it's going to be an exciting era for everyone, particularly for architects. With this metaverse coming up, I think architects are going to be exposed to a set of tools and experiences that allow them to express and explore more about the design and the architecture. So for us, the principle is to build the platform, both hardware and software, that would allow architects to play with their ideas and explore ideas to the level that they have never been exposed before. So from the architect's perspective, I think we wanted architects to start being familiar with a set of tools that we will be providing that would help them to explore more in this field. So I think having that expertise in architecture, and in addition to that, having familiarity with the machine learning or tools that help the architects to explore AR, VR world, I think would be a massive advantage. So in my view, the next generation, next set of architects, would be the ones that would have both expertise on the architecture itself, but also some degree of familiarity with AR, VR, XR, and AI world. I think that would make a great architect going forward. Thank you.
Yes, and to increase the degree of familiarity, I think it is good to involve this technology in our education. Do you think so?
I mean, personally, I would think so. I would agree. From our perspective, our job is to build an interface so that even general people who don't have background in computer science could easily use tools to explore their ideas and create some new opportunities, right? But it doesn't hurt, obviously, if any architects or future architects are in fact familiar early or got early exposure in their early education. I think that would make the pipeline even better. Thank you.
Thank you. And right now, you are now in Indonesia, in holiday, I think. What do you think about the development of this technology in Indonesia? How to catch up the gap, and what will be the development challenge for us right now? And you may also give us alternative solutions for that.
I think based on my limited observation, I've seen a couple of startups are actually trying to get into this business. So every year in the US, pre-COVID, there's a annual conference about mainly focusing on startup. It's called South by Southwest, and everyone is building their new ideas and startups. Typically come to the South by Southwest and then present or showcase their ideas. And I think for the past 3 years, I've seen a lot of startups coming from Indonesia are actually always, at least, a couple of them always focusing on AR and VR. I remember one of them was actually doing some sort of a digital architecture using AR and VR, and how one can explore the realm of digital architecture assisted by the AR and VR. So again, I have not lived in Indonesia for quite some time, so I don't really know the state of the art, but based on my limited observation at the times when I was in the States, I think it's exciting to see lots of young folks are actually starting to go down this path, and it's just exciting to see that they're exploring this idea. Thank you.
Okay. Yes, it sounds good that you have seen startups from Indonesia that have relationship with digital architectures. Yes. And the next question, we have a lot of development in the use of AR, VR, and also AI. But on the other hand, I think we also have various conceptions that saying AI will replace the position of the architects, and somehow the data is not really secure, and etc. What do you think about this phenomenon?
I think I've been always asked questions like that. I think I don't think we're there yet. I think we're still quite far.
Okay.
I'm not saying that we won't get there. I'm not saying that, but think about it. 100 years ago, probably. If you think about industrial revolution, where machines were kind of like feared, we're going to replace human beings, because all the human or manual labors in the factory were going to be replaced by machines. And in fact, we as humans would, in my view, would always be able to find some sort of like synergistic relationship between us and technology. It's not like one is going to overtake another, but I think it's been always the case since the Industrial Revolution that we would find a way to be cooperatively and synergistically work together. Obviously, some of the works that exist today potentially are going to be replaced by AI at some point, because the precision and the accuracy that AI can provide is humongous. But then, there's always next opportunity how we can leverage the next set of interaction and synergy between AI and human beings. So I wouldn't see it from a negative perspective or scarcity perspective. I would see it from an exciting opportunity that would be awesome going forward. Thank you.
Yes, I agree with you. So we have to see that VR, AI, and other technologies have to seen as tools to empower us and our architect. Yes. So about working with technology, do you think that multidisciplinary skills are required?
It's always required, I think.
Yes.
I think, but I want to say it in a careful way. I think multidisciplinary is very, very important, provided that you have a very good basic for each discipline. Multidisciplinary would not work if you don't have a solid understanding of each discipline, because it won't take you anywhere. Things start to connect when you understand very deeply multiple things together, and new solutions that have never been proposed before could stem from that, provided that the basics of each discipline are strong enough. So I'm always an advocate of multidisciplines. In fact, in our research labs, we are always encouraged to collaborate with people outside our disciplines and try to learn from one another. So I think it's always been important. But you know, in some cases, people are overhyped about this, and instead of like understanding and having a solid understanding for each discipline, they just like have a shallow understanding of each discipline on the surface. And unfortunately, in that case, I don't think innovative ideas could stem from. Thank you.
Okay, thank you. This is the last question. Would you mind giving us some tips to adjust with this technology, and also give us tips where shall we start to adjust those things?
That's $1 million question. I don't know. I think engineers, at least as an engineer, I would encourage everyone to stay curious, and to stay curious and always be willing to learn what's the new technology, what's the new opportunity, new potential from every new technology, basically. Because the more you know, the more you're curious about something. I think the more you're willing to learn, and the more opportunities that you will see. So it's time to get rid of the pigeon box of limiting yourself to be just a person. I think one would need to stay curious and be open about what new expertise or domain she or he could potentially learn from. And I would encourage everyone to stay curious and learn from different domains and expertise. Thanks.
Okay, thank you very much for the lively session with you, Mr. Asri. That was such a great conversation. Good luck on your career pathway on Facebook and keep inspiring us. Yes, then dear participant, it's now the best time for me to wrap up the highlighted points from we have had during the second session. While I wrap up everything, you may please access the Google form, or you can drop it on chat box for the brief Q&A. So yes, in brief and short, first, Fukuda Sensei delivered his impressive talk about technical development of digital architecture, and we have heard that several topics that are explained as an application of digital architecture that he has delivered. First is mixed reality to outdoor landscape simulation. This has been comprehensively elaborated in step-by-step stages, putting 3D models on the game engine, including how AI can help handle the dynamic occlusion. And then the second, the integration of architectural planning and environment using the extended reality in the initial design stage. And then the third, the DR simulation with 360 degrees of live streaming for renovation study. I believe that this is a very strategic simulating space renovation in terms of reading plan layout, capacity, and ambience. And also the next future meetings or collaboration style. This was the remote sharing of 3D real object using high-speed cloud point and mixed reality. Second, Professor Joko Budianto mentioned fantastic about artificial intelligence for the future architecture. Professor Joko has explained in detail the development of artificial intelligence and made us aware that we live in the era of big data. This development also have an impact in the field of architecture. There are also potential problems such as divergent problem solving, and Professor has also mentioned the alternative solution. The professor also gave an example of an AI application for sketching with the Japanese house case. In the future, we can still have more exploration as stated in more lamp. Changes are exponentially. Last, Mr. Muhammad Asri has brought us to the remarkable ideas of Meta, a Facebook metaverse empowered by AI, which is the next opportunity for architects and others. I think we have explored so many things about AI and architecture in the second session. now we are move forward to our very interesting part, the question and answer. We will have two first question, and I will pass its respected question to each presenter. So, yes, I will look from the chat box. Okay. Dear audience, so if you haven't come up with a question, you are all invited to drop off your question on the chat box. Do you have any question? It is a really interesting session from Professor Joko Budianto and Mr. Muhammad Asri. So I don't think we have any question here.
Panas di luar.
Okay.
Hah? Udah dari jam 1, cuma Anin kebagiannya baru mulai.
Maybe I will have a question for Professor. Yes, maybe I have a question for Professor Joko Budianto.
Okay.
Yes, from the architecture field, I have read that the artificial intelligence will be very useful, and it has various domains. From machine learning, there are robotics domains, natural language processing, fuzzy logic, and also expert system logic. Which one do you think will be more impactful to the creative process for the architect? Maybe you can you also can describe it in a very clear way for us as an architect.
Okay, thank you. Thank you. I think AI is the most influence in any, in any area. AI contains machine learning, like I said before, vision computing, soft computing, many things. Like what Dr. Muhammad Asri said, pervasive computing is right now also developed. It can influence also in I think in any area, not only in architecture, I think. So like predicted by economists, but that's many things will be influenced by AI. So as in the our first slide, that almost 15% human will be, the job of human development will be replaced by AI. I think it is my answer for this question.
Yes. Thank you very much, Professor Joko. Yes, I am still waiting. Other question for other participants? So, if we don't have more question, so we are now already reached the end of the session. With all gratitude being expressed, I would love to send my deepest gratitude for all of our keynote speakers today, Fukuda Sensei, Mr. Asri, and also Professor Joko Budianto. Thank you very much for being here. And also to all participants and attentive viewers, thank you very much. I wish you all a pleasant day ahead and all the best for you. Goodbye for now. I am handling back this session to our Master of Ceremony. Thank you very much.
Thank you, Professor Astrid. Mr. Tomohiro Fukuda, Professor Joko, and Mr. Muhammad Asri for the great presentation and discussion. Excellencies, ladies and gentlemen, the end of the second panel discussion concludes our webinar today. As this is the end of today's webinar, we would like to deliver our gratitude to our distinguished speakers and moderators for the impressive discussion today. We would like to remind all participants to mark your attendance by accessing the link to fill the online form that is provided in the chat box. And to all presenters, we inform you that parallel sessions are asynchronous. All videos of presentations, questions, and answer activities can be viewed through each participant's conference account. We will open parallel session for 5 days, 13 to 17 of December 2021. Presenters can take the time to check their respective accounts if there are questions from other participants. Excellencies, ladies and gentlemen, thank you to all participants for joining us today on the first day of IWEDA 2021, and also thank you for your support in the participation during the discussion. I hope that today's discussion could give us more knowledge and bring us to experience new things. And finally, I would like to apologize for any mistake I made while I served you as the MC today. Once again, thank you for your participation. Good afternoon and see you tomorrow.
you.